Hey guys, welcome back to Rocket Gyan, my fellow space tubers, and today we are here again to witness this amazing launch. Let me just see what is happening. Why aren't you seeing this? I think is it visible now? Could be. Just a sec. Let me just see. Was working before. Okay. All right. Amazing. Something has happened right now. Why is it? Yeah, there you go. Okay, so guys, welcome back to Rocket Gyan, my fellow space tubers, and today we are here to witness this launch of this amazing rocket in front of you, the Firefly Alpha rocket. And this rocket is itself unique because they attempted to launch their rocket in 2021 also, this Firefly company, and were unsuccessful because one of the reaver engines which they have decided not to turn on, and because of that they did not reach their perfect amount of thrust, and the thrust to weight ratio was not good enough for it to reach that speed, and hence much of its fuel was wasted and the mission was not a success. But now they have resolved that issue, and we are back again here to see the launch of the Firefly Alpha rocket. Before we get into this rocket, first of all, this rocket itself is very beautiful to look at. All black paint job with a silver fairing. It looks amazing. And we are right now T-minus 5 minutes from the launch, T-minus 1 hour and 5 minutes from the launch, sorry for that. And we'll be looking at the mission and what do we have in store for us for this mission today. And yes, we'll go through everything else. So first of all, welcome to the stream, John Nakashima Yosuke, if I pronounced your name right, Sluneko, Rajesh, and Carpenter. So welcome to the stream, and I am very excited for this I won't say this inaugural launch, but again, this will be the launch. If they are successful, they'll be in the elite club of spacefaring organizations, spacefaring companies. Yep, that would be the perfect word. Okay, now let's have a look at this rocket itself. So for that, there you go. Hi Space Maniac Zach, welcome to the stream. This is the rocket, and we will be looking at let's explore this rocket a bit further. So this rocket is a two-stage rocket. So there you go. This rocket is a two-stage rocket with the first stage powered by 4 reaver engines. These 4 reaver engines. So these engines burn on tap off power cycle, which is very similar to that gas generator cycle, which I'll show you also, like what's the difference between, but they are similar but not exactly same. So this is the reaver engines, 4 reaver engines producing a thrust of around 736 kilonewtons total at lift off, and has a tap off power cycle. So this power cycle is also used in the BE3 engine of the New Shepard, Blue Origin's New Shepard rocket, and this tap off cycle is indeed the simplest cycle which you can have after the pressure fed one. And then we have for the second stage we have the lightning lightning 1 engine produces around 70.1 kilonewton of thrust at ISP of 322 seconds, and this is also a tap off power cycle, and this is, both of them uses this what should I say, RP1 and LOX as its fuel. So one unique thing which you will notice about this engine is that the exhaust pump or exhaust here is actually being fed to the combustion chamber, to the nozzle of the, not the combustion chamber but the nozzle itself. So it's not going inside it, but just a nozzle, so that it can cool down the nozzle. So the engine's nozzle extension gets cooled by the exhaust gas of the turbo pump, because turbo pump operates at a lower this turbine of this exhaust operates at a lower temperature than the combustion chamber, because if it would be at a higher temperature or at the same temperature as the combustion chamber, then it would melt and would not do the job. So that's why we have that. So this is how the rocket looks like. When you see it in person. Obviously this also, like, you know, is a huge rocket. It's not a small rocket, which you will see also with when I'll get to it. So let me just, yep, let's have a look at the company itself now. Like, what the hell is Firefly and where did it come from? So this Firefly Aerospace has been in development since a long time, and they already tested their first flight. They had their inaugural flight, Alpha, the flight 1, which they say, and that was not a success. It's very rare that a rocket becomes successful in their first flight itself. So yeah, this was no exception, and this is a company which is trying to meet end-to-end space transportation and in-space services. So not only it provides rockets to make sure your payloads reach the orbit, but also has this SUV. Yep, the SUV, which the car, which type of car which we have, but it's like a space utility vehicle. Here the full form changes. So it's like a space tug, which this rocket lab also have the Photon. It's a space tug which has its own propulsion system, own communication system, the power requirement, everything, so that a satellite, the small satellites, the CubeSats or the PicoSats, can deploy to their desired orbit. Because these satellites, mostly what happens, they are having a ride-share missions. So at a particular orbit which they require is not achieved by that ride-share mission. So that's where the space tug comes into picture, and this is the space utility vehicle which we have. They also have this blue ghost thing, which is back to the moon, which is nothing but a lunar lander or moon lander, whatever you wanna say. And this is supposed to land on the moon by 2024, having like around 10 payloads of NASA. But NASA has already given the contact to them. So yep, they are also building a lunar lander. So there's that. And but today we will be focusing on their Alpha rocket, which has a beautiful design. This phoenix coming out of the lava, and just looks amazing. Yeah. So yeah, let's have a look at this rocket itself now. So this rocket itself is a very okay, yeah, is a unique one, because the payload capacity is 1.1 tons to low Earth orbit 200 kilometers. It's not a small sat launcher, because it's more or less comes into a medium sat launcher category, because it obviously can lift heavy payloads greater than 500 kilograms, and payload to sun synchronous orbit is around 745 kilograms, 500 kilometers. So there's that. So it is, the propulsion system is 4 Reaver engines, as I discussed. Propellant is LOX RP1, and it works on this tap off power cycle. So we'll talk about this tap off power cycle in a bit. So you can see the thrust rate produces 736 kilonewtons, ISP of 295 seconds, which is good, which is great, even I should say, for not great, no, it's not great, it's not great for a RP1 cycle engine, RP1 fuel, because yep, it's an open cycle engine, so we can't expect much from it, but still it's a good one to start with. Now regarding the second stage is a Lightning 1 engine, again powered by LOX and RP1, thrust of 70 kilonewtons. This is also not too great, but again it's good. 322 seconds of ISP, which is great. And you can see the overall length is around 29, almost 30 meters in length, which is huge. And then the payload fairing is again stage 1, stage 2, you can see little bit stage 1, stage 2 has the same diameter, but the payload fairing has a bigger diameter, which you can see if I open up this, you can see all the parts, the oxygen tank, the fuel tank, the oxygen tank, and the payload here, which you can see. And then again this the same scenario for the below part. Now again this is how, you know, inside the fairing looks like. the vibration dampening things here. This is nothing but a payload adapter. Would not get into details of it because it's not much of importance today. And then yes, we have talked about all this. So let's have a look at this cycle, this new type of cycle which you are hearing right now. So this is a tap off cycle. So this tap off cycle is an open cycle, which I said. So it has an exhaust from which the plume comes out, and that exhaust, you can see it's an open cycle because it is not going inside. This exhaust obviously drives a turbine, which in turn drives the turbo pump. So you must be wondering, like, it is very similar to gas generator, so why aren't we calling it as a gas generator? So if you are a rocket expert and a rocket nerd, you must have already seen what is missing here. It is missing a pre-burner for a gas generator cycle. So gas generator cycle here has a pre-burner. So that pre-burner has a job of combusting the fuel a little bit, so that those fuel can be fed to the turbine. Here from the combustion chamber, the hot gases from the combustion chamber itself is fed into the turbine. So there's the difference. You are eliminating the use of pre-burner and hence making your engine design way simpler. So what happens here is the fuel is pumped here, which you can see. Heat exchanger is obviously, you know, kind of optional. Some people can go with it, some people don't. And then it is fed into the combustion chamber. Here the oxidizer is coming here, but from the combustion chamber the hot gases are then fed into the turbine, which rotates the turbo pump. So this is how the things look like, and those hot gases are then just given out. But you must need to understand one thing, that the combustion chamber has literally, like, you know, the gases temperature is top of the roof. So and the turbine can't handle those temperatures. So because of that, it must be having some cooling mechanism in between the pumping, the plumbing, like that, so that those hot gases can cool down a bit, and then it can run the turbine. And for the second stage, the exhaust which is coming out is again fed into the the side of the nozzle, so that it can cool down the nozzle. So there's that. Hence you can see it, since it is using to cool down the nozzle itself, so therefore you can see the temperature of these gases. So yeah, this is how the tap off cycle, this is the rever engine, this is how it looks like. It is a very, very, very simple engine. This is in front of you. So here is that turbine which is rotated, used to rotate these two turbo pumps here, and then the exhaust gas is just given out. Here you can see the engine, the single engine, but four of them are used. So the four of these engines are clustered like this, and you can see all of them together here. So it kind of looks like a bit more complex here, but still it's not that complex than a gas generator or normal engine. So yeah, there you have it. So since they are saving the space of this pre-burner, therefore they can have more of the plumbing in there to make sure, and more of the wiggle room in there to make sure that the engine has much more gimbal ability. So yeah, there's that fun fact also. So let's move on to the payload section now. We have talked about all the things which we needed to know about the rocket. Let's have a look at the payloads now. So the first payload which we have is from the Teachers in Space. That's what we call it, the Teachers in Space. Amazing name. Teachers in Space Serenity, as they say it. And this thing is a simple Raspberry Pi which satellite, which has those temperature sensors, those radiation sensors, and all those basic sensors which are needed. But this is mainly to make sure the students can have a good understanding of the space. They can be more aware of the space, and they can be more involved in space. So this is, there you go, the Teachers in Space satellite. Then next we have this NASA's TED mission, NASA test mission, test 15 mission, Tech EdSat. And this is a very unique satellite, because this satellite is this satellite is very unique in oops, wait a sec. Yep, not looking. Yeah. So yeah, this satellite is very unique because this is demonstrating a kind of technique which can be used to recover the things, recover the things which are sent into space using CubeSat. But then the CubeSat can also be like recovered. So like what is happening is, this is testing a special type of recovery system which can be deployed on a CubeSat, which can be installed in a CubeSat, and that deployed system can make sure that the CubeSat can survive the harsh climate, harsh effects of re-entry, and it can land safely on Earth. So the sample return missions, the landing on Mars, all those things are the potential applications for this. And this is how it looks like. So it's kind of a very sophisticated system. It's not like a solar sail or something, because it is able to it's not a heat shield also. So it's kind of a system which has its own those navigation system. So this is a very flexible one. It can deploy in certain angles so that it can control the flight, control the orientations, and then finally make sure the CubeSat can land safely on Earth. So it's a very different system, a different technology, but it would be very useful in those sample return missions, because the sample return capsules are almost of the CubeSat size, and the missions in Mars. So yeah, there you go. Talking about the next thing, the next payload is this, from the Libre Space Foundation. So this is an open source foundation. They are making sure the space is open for all. So this is a Pico bus, cubic 1 and 2. It will deploy 6 pocket cubes, so Pico satellites basically, and they are having a deployed system as well as this CubeSats. So these CubeSats will conduct again those amateur radio experiments with its 2 satellites, and it will, since all the data which is coming in from it is in open source, so it is available for you to explore also. Okay, and this is their motto kind of a thing, which is there on all their satellites, so you can read it. So it's an open source one. So if you are a computer science engineer also and looking to contribute in open source and interested in space, Libre Space is the way to go. You can check out their GitHub repo for more updates. Now moving on to the next thing. Yeah, so we have other satellites from AMSAT and the FOSA systems, but let's move on to this one, which is in front of you. So this is a non-technical payload. So there is something called a art capsule which is flying on this Firefly rocket. So this capsule will have artwork provided by teachers in space, the Girl Scouts of Austin and Jonna Ocampo. So teachers in space will send 128 postcards to orbit made by students, again to make awareness. The Girl Scouts of Austin have provided a space artwork that will hitch a ride to space. And then we have this author Jonna Ocampo, who runs the self-funded non-profit organization CDCs. He has written a children's book titled Henry the Astronaut, which you can see here, and this cute little copy will fly onto the space. It also flew on the space on this rocket during the inaugural flight also, but obviously it was lost, so it is flying again now. So there you go. Now let's have a look at the mission profile itself and other things which we need to know. So here you can see the payload mass is around 35 kilograms. The payload altitude is 300 kilometers, and inclination of around 137 degrees. So it's okay, so it's kind of a retrograde orbit which it is going into. So yep, that's something. And now Okay, so there you go. Only 35 kilograms is the mass, so it's again a technology demonstration mission, so can't expect much. And yep, this is the mission profile. The stage 1 ignition liftoff, MECO stage separation at around t plus 160 seconds, and velocity will be around 3 kilometer per second there. Then the stage 2 will ignite, the fairing will separate, and the CECO 1 will happen. So that's the ascent phase. Then we already have had a look at these things. Alpha rocket, and yes, the stage, there will be two CECOs. So it will have an elliptical orbit first, and then it will coast to the apogee for the second engine start. Once it starts again, most likely and very similar to the SpaceX trajectory, because many of the SpaceX engineers are there working in Firefly. So and one of their leading rocket engineers, rocket engine designers, sorry, Tom Mueller, also helped in the development of the Reaver engine. So yeah, there is that. So SpaceX legacy goes on in this launch. This company also. So without any wasting further, without wasting any of your time, let's move on to the launch itself and see what do we have here. So yep, this thing is provided by Tim. So first of all,
the wind has picked up like crazy.
Oops. Credits to him for providing this launch stream. Yep, the Firefly does not have any of its official launch live stream, so there you go. Tim will be hosting it, and I'll also do my job. So if you have any questions, you can ask me too.
What this vehicle can do, this vehicle can do a lot more than this, but it's currently, for this mission, only flying about 35 kilograms of payload to low Earth orbit. This vehicle is capable of about a metric ton to low Earth orbit, so it's quite a formidable rocket. It's only taken 35 kilograms this time, though. Yeah, keeping it nice and easy just to test out the systems, make sure everything's good to go before they start putting larger operational payloads on board. So this thing is going to a 300-kilometer low Earth orbit at a 137-degree inclination.
So yep, Sluneco, they are launching from Vandenberg Air Force Space Station. So there you go. Mentioned in there also if you read it from there.
But yeah, as you guys know, maybe if you know anything about orbital inclinations and rockets, basically if you're at a 0-degree inclination and you launch from the equator, you'd be going just zipping around the equator. 90-degree inclination would be going over the north and south poles in a polar orbit. Anything beyond 90-degree inclination is actually retrograde. So they're actually flying in the reverse direction that the Earth is spinning. The Earth is spinning, east relative. So it's actually flying backwards, which is super unique. The main reason they're doing that is just so that they're flying further and further away from land, just keeping it a nice, safe corridor for a vehicle's test flight. This is, again, a test flight of this brand new rocket. This is their demonstration mission. They're just keeping it nice and safe, so they're actually flying a bit west. So 137-degree inclination.
And that something also explains why they are having such a small payload in there, only 35 kilograms, because they will be cancelling out the Earth's velocity first of all, and then gaining the velocity of the orbit. So yeah, the payload capacity will decrease, but not this much, but still.
Again, that's not a capability of Alpha. So these are brand new fairings, and again, this is only the second launch attempt of this vehicle. So this would be the second launch of the Firefly's Alpha. This is the second launch for the company altogether for Firefly. This is the first launch of Firefly in this year, in 2022. The 10th launch from Vandenberg this year. So Vandenberg Space Force Base has been pretty busy, and I think they're going to get a lot busier here in the future. And this is the 116th orbital launch attempt of this year. That is a number that when I first started, paying attention to spaceflight stuff in 2013, 2014, a number that I didn't think we'd see coming this quickly. So things are getting busy. So we've got a little bit here on our website again about what this mission is, what they're doing, all of the fun things at everydayastronaut.com. The things that I did want to talk about, there's there's a handful of small sats and CubeSats on this, but I did want to talk about one in particular. It is the Teachers in Space Serenity payload, and I think we actually have a video of that. So we're going to play a little video to teach you more about this payload.
On this upcoming mission, we have 3 payloads flying with us. All of them are very experimental and heavily into research and development, and specifically about raising awareness in space.
Teachers in Space, we provide actual space opportunities for teachers to actually be embedded in preparing a rocket for launch, preparing a satellite, integrating the satellite. Firefly have given us a brilliant opportunity to launch our own first educational orbital satellite.
The idea behind Serenity was to build a carrier that we could use for student experiments. Now we're doing the ultimate test on orbit. And if it turns out to work, now we have a tool that we can put in our tool belt to help astronauts with radiation.
We're putting a blockchain experiment into space. And what we're looking for is to test how we can communicate efficiently from the Earth to blockchain satellite, perform various types of transactions. This is the beginning of several types of experiments we want to do to test the limits of blockchains in space.
I'm looking forward to the Serenity 4, 5, and 6. I want to see what those are going to look like and what experiments the students are going to bring. We want to give them the opportunity to put that on orbit and do something amazing.
We are up and running between the teaching, the launching, and the receiving and analyzing and presenting of the data, and it's like we have our own space program for teachers.
So yeah, that's a pretty exciting payload that is on this rocket currently, but there's another one that I'm actually really excited about too. This one is called NASA's TechEdSat 15. And what's interesting about this thing, we'll learn more about it here. We'll pull up a video here in a second, but I want to just kind of tell you why I'm excited about this. This is a NASA demonstration mission that's actually working on deorbiting small and CubeSats and things like that, because as you know, we're launching more and more vehicles into space. Being able to get them down in a timely manner is extremely important. So this is a technology demonstrator, and so I think we've got a video here we can roll for you guys. Let's check that one out.
Yep, things are heating up in space, and this is one of the examples.
NASA's mission is to help stimulate and advance commercial space. We collaborate with our young professionals within NASA, private industry, universities, and basically use this as a cauldron to advance a lot of technologies through experiments. In this case, it's helping to supply a very quick turnaround nanosatellite to the Firefly team.
The Tech Education Satellite Series is a rapid protoflight series of incremental CubeSat developments. It's a good pathfinder for new launch vehicles, which helps reduce the risk that we have for other NASA missions.
There's so much you can do with small cube satellites. I mean, we can help with climate change. We can help with climates in Mars, climates in Venus.
We're doing pathfinding efforts to enable, manufacturing and low Earth orbit.
We're really interested in taking the nanosatellite concept and moving that to the lunar environment as well as Mars.
Our primary payload actually for TechEdSat 15 is our exoatmospheric braking device, which we like to call our ExoBrake. Our ExoBrake is made out of a material that's the same exact thermal blanketed material that was on the space shuttle, which enables us to have a certain amount of control authority in regions of our atmosphere where most other CubeSats cannot.
We're also flying solar panels that are commercial off-the-shelf units. It lowers the cost of the most critical component of our satellite.
I could actually command the satellite using email actually. When we were quarantined at home, I was actually commanding satellites in my bedroom.
I got my aerospace engineering degree from San Jose State. You're taught very practical things from the get-go that translated almost seamlessly into industry work, especially at NASA, and integrating here with Firefly.
SGSU is in a very strategic location. Being next to NASA Ames Research Center and being near Silicon Valley, we have an opportunity to work with technology that's actually cutting edge and then be able to apply that in a space environment.
My generation was involved in watching all the Apollo launches when I was a child, and always wanted to work at NASA and teach and be part of this.
We have the job of turning science fiction into science fact.
It's an opportunity for me to also work with our younger staff and excite them. They're going to define the next generation of space and space exploration.
So yeah, that's a pretty exciting CubeSat on this mission. But there's also 3 other small CubeSat and small sats here as well. So go ahead again, read through our entire pre-launch preview. It gives you a really good sense of some of the exciting things on board, including a Firefly capsule filled with artwork as well. It's just really cool. And this our website will also give you a rundown on the mission profile, the mission timeline, which you can kind of get a sense of where we're at here. We are coming up on that terminal countdown in about 17 minutes. So things are moving right along here. We have not heard any other updates. But yeah, so go ahead and read through this here. This particular article on our website was written by Flo, or Florian. So thank you, Flo, for writing this awesome article. If you guys want to read through that, just say thank you to Flo for writing such a good article for us, and our whole web crew for keeping everything up to date and keeping us in the know here while we're hanging out. So yeah, I have a few more. I know this is not normal for me. Thank you guys for watching. This is so exciting for me. We've been working really hard to be able to bring you guys coverage, working so closely with the amazing people at Firefly. They've been just incredible to work with. I mean, I can't even tell you how fun it's been. We are using the van. People are asking if we're using Luna, our locational uplinking networking asset, our old production truck, providing this 4K stream. And boy, is it looking good. It has been amazing. Andrew and Andrew Taylor, and especially Ryan, and especially Andrew and Ryan have been working really hard. Ryan with Cosmic Perspective have been up all day and night trying to bring you guys some footage here. So yeah, we're quite pleased to be on set here. It's just been amazing. But I have a lot of people I need to thank at the top of the show, because honestly, I mean,
All right, guys. So yep. So hey Ben, how are you? So right now we are at tanking operation. So you can see the Firefly is kind of venting liquid oxygen, which means it is kind of right now fueling up. It will fuel up and then top off the liquid oxygen. So there's that, and today this thing is carrying around 35 kilograms of payload to low Earth orbit, that to a retrograde orbit. So that is one unique thing which it is going to do in its first flight to space. If successful, the second flight, but if successful, it will be first flight to reach space and when orbiting. So we'll see if it will be able to do that, since again this is a technology demonstrator flight. So it's not a thing which they have developed fully. So therefore there might be something you might not like, maybe a failure, maybe a rud, or some kind of a thing, or maybe a scrub, or maybe a delay. So there is that. But right now the countdown is holding up. T minus 35 minutes. T minus 35 minutes, and the weather is 60% go for the launch. So there's that. So weather was 70 before, now it is 60. Oh, it's not a good thing. Let's see. All right. Okay. So there's a very good view of the rocket. You can see this has a very unique paint job, a black kind of carbon black finish. They have done the paint job specifically for that purpose only, and yes, that paint job is also carrying a definite weight on it. So there you go.
Where's your new Luna van? It is right over my shoulder. We didn't have it in the background of this shot this time because, frankly, we thought this old NASA hangar was a little bit better background, which is really cool. We're literally, I gotta tell you a fun little story here. Vandenberg Space Force Base is an amazing place. There's so much history out here, tons of incredible launch pads. But perhaps one of my favorite things about this base is actually the fact that NASA was working on launching the space shuttle out of here. So Chris Bergen, there you go. You got your space shuttle reference. This base actually had the Enterprise come out onto the base. They landed it here at Vandenberg. They trucked it over. The craziest thing is they literally cut into the mountain that's in front of me, and they had to carve a path for the wings into the sides of the mountain in order to actually get that thing through this mountain pass. So when you drive up the road, you can actually see the mountains cut out and has these little notches in it where the space shuttle's wings went in order to bring it into the hangar here. Then from the hangar, it was going to be processed, and it was originally going to go out to Slick 6, which those of you familiar with Slick 6 is currently Delta IV Heavy, which is actually, they have a Delta IV Heavy on the pad here. They're a couple weeks away from a launch there. Yeah, like I said, Vandenberg is just full of some really, really fun history, and it's been cool to see Slick 2 here, which used to be a Delta II pad, how different it is compared to when I was out. The last time I was out here for a launch, was in 2014, OCO2, Orbital Carbon Observatory 2 or something, flown on a Delta II for a NASA mission. And yeah, that was super foggy, but the launch pad looked so different compared to this streamlined and simple.
So Suneko says, will they ever be able to have a larger payload if they go west, or will they have to move to the east coast eventually? All right, so it's a good question actually. So right now they are at this Vandenberg Air Force Space Station, because right now they are going to a retrograde orbit, right? And they need to go in that direction. Most of the time, what happens is from this Vandenberg launch station, most of the rocket goes to a polar orbit, because it's up north, and yeah, you can go to that orbit more easily from there. And in retrograde also, the same thing is there. It can go to a retrograde orbit from there, but the thing is that yes, it would be easier if they launch from Florida, if they need to go to a normal low Earth orbit. So if they are planning to, this will happen. Right now they are aiming for this Vandenberg station only, because they will be launching two sun synchronous orbit, and the polar orbit supports a good polar orbit launches are a good way to launch from this station itself. So that's why they will be launching it their rocket from here initially, but they may shift to Florida or Cape Canaveral, or those things. So yeah, I think that should answer your question.
The people that actually plan the trajectory, what extra, how they take into the Earth's rotation, and I would love to see those calculations. I wouldn't understand a single one of them, but it'd be fun to see the difference between flying retrograde and planning that orbit versus flying prograde. So, yeah, this is. Oh, thank you so much from Ankla. Yeah, again, huge shout out to everyone involved to make this possible, to be able to stream this in 4K. I don't know if you guys know how hard it is to stream in 4K. It is not easy. It is not easy to do it well and do it right with minimal lag. I mean, we are the feed I'm actually seeing here is like only a few milliseconds from real time to my eyeballs, which is just incredible. And then of course YouTube takes a little bit of time to get to you guys through YouTube and through the cloud and stuff. But it's pretty low latency, and it's 4K, and it looks incredible. And look at that vehicle. I should answer this question because I do see it a lot. Right now you can see some condensation pouring off the rocket. That is totally normal. That's because they're using cryogenic oxygen. So oxygen becomes liquid at cryogenic temperatures, which means it's extremely cold. So they're loading the vehicle with liquid oxygen, which I believe, ooh, dang it. Off the top of my head, I believe minus 186 degrees Celsius. I'm probably wrong, but that's what, or 183. That's the, off the top of my head. Really, really, really cold. It's very cold. And you do that so it can densify, so you can get a ton of your oxidizer into the vehicle and into the oxidizer tanks. And then it has RP1, which is basically a refined form of kerosene. That's the fuel. So there's, of course, a fuel and an oxidizer. But in order to make the oxidizer liquid, you got to chill it down to be extremely, extremely cold. And that's what they do. So they actually chill it down to liquid temperatures, and then they load it into the vehicle. Now, of course, the vehicle, we're sitting out here. It's California in a bit of a heat wave. In the ambient temperature out here, it's 82 degrees Fahrenheit. So what is that? I don't know, 30-ish degrees Celsius. It's quite warm. So of course the ambient temperature will warm up that liquid oxygen while it's sitting inside the rocket. And when it does that, the liquid oxygen boils off and becomes gas. So what you end up seeing is you actually see them venting the gaseous oxygen to maintain the pressure in the tanks, because when it boils off, and imagine like a kettle boiling or any water boiling, as it boils from liquid to gas, it expands, and you have to release that pressure. Otherwise, you could have a boom in whatever containment vessel you have. Same type of thing here. Liquid oxygen. If you warm it up, it expands, turns into a gas, and it expands almost 1,000 times. So you do need to vent it. And so what you're seeing is still very cold oxygen, but it is now gaseous. It's coming in contact with the humidity in the air. It's making some little vapor crystals. That's probably the longest explanation I've ever had there. Sorry if that's totally just the longest-winded thing you've ever heard. But that's why you see that venting and those cloud vapors coming off of the vehicle. One thing we will be able to see, hopefully relatively soon, as the vehicle does fill with liquid oxygen, you will actually see this vehicle is made out of carbon composite. So it's a carbon fiber rocket. And as it gets colder and colder and colder, and as the vehicle fills up, you will see the black carbon fiber turn white because of frost. So yeah, we're seeing a lot of activity there. I'm excited to hear what exactly that is. That's a lot of stuff happening. We'll see if we can get an update on that. We have another exciting thing for you guys. We are able to bring back trench cam for you guys. This time it looks even better than last time. That camera is going to be seeing a lot of crazy stuff. You can see it's in a pretty protective housing there to be able to handle the flames and the high velocity hot gas coming out of the rocket when it ignites. But that is the flame trench, the flame diverter. As the vehicle lights its engines, the flames will shoot through that flame diverter and off to the side, clear of the launch pad and launch infrastructure. So that's really, really cool. Can we show that yet? Oh, we can show it. We do also we'll be able to show this for just a brief moment when they go to light these things, but that is the engine cam. So we also will be able to hopefully provide that right when they go for liftoff. So super exciting. I mean, these are camera views that, come on, this is absolutely incredible. You can see the 4 Reaver engines on the vehicle there.
And yes, they
those
are
Reaver
able to
engines
provide these views because they have already covered all those plumbings and everything. So, yep, that's why they are able to provide these engine cams. But otherwise, we wouldn't be able to see these things. Most probably, this happened. So, yeah, kudos to them.
Are the Reaver engines. The tap-off is really interesting. I had a really deep dive video on all of the different engine cycle types, because a rocket engine cycle type is sort of like, it's almost like a car, how a lot of internal combustion engines, they all utilize the same piston engine process, unless it's a rotary engine or something. But, typically all run on the same process, but they employ different tactics and techniques to develop power. So sometimes they're naturally aspirated, you might have turbochargers or superchargers, or, Atkins cycles, all these different tweaks to the familiar piston engine. It's kind of the same thing actually with rocket engines. At the heart of the rocket engine is the combustion chamber going through a de Laval nozzle that converts the high pressure hot gas and converts it into high velocity lower pressure gas, and that's what makes it go really, shoots the exhaust out extremely fast. But in order to power that, you have to have instead of high powered, you can either use high pressure tanks, which is actually what Firefly, when they were Firefly Space Systems, had utilized was pressure-fed engines using high-pressure tanks. So the tanks of the rocket were actually under extremely high pressure.
Astra uses the pressure-fed engines in their second stage, so there's that.
When they reformed and became this new version of Firefly, they actually ended up with the tap-off cycle, which is extremely unique. Basically, you take your combustion chamber where the fuel and the oxidizer mix and then, ignite and blah, blah, blah. You actually take and, for lack of a better term, you punch a hole in the side of the combustion chamber, you pipe some of that hot gaseous propellant, and you actually flow it through a turbine. You spin up that turbine using the combustion engine, using the combustion from the engine to power the pumps, which is like the ultimate chicken and egg scenario. Like, how do you get the pumps running if the engine requires the pumps to run, but the engine itself is running the pumps? Like, it's the craziest thing ever, but it's actually a really unique, very simple, and extremely reliable system. Firefly has had, when I talked to Tom McCusick last year, they had just basically said they had the absolute best luck with this engine so far. At the making of that interview, they had not even blown up a single one throughout the entire testing campaign, because the engine's just so simple and reliable, yet very high power. That's the cool thing, is you kind of get the best of both worlds. So I'm really excited about this. I think the tap-off cycle is an engine that I'm just excited to see fly. And I'm excited to see it fly with my own eyes this time. That's something really exciting. So, yeah, other than that, it looks like we might be having some problems with my camera. We might need to power cycle this camera here for a second, Ryan. But we've got a lot of things. Oh, so this is Jack Beyer, who is with NASA Spaceflight, is giving a shout out to
Alfonso, welcome to the stream.
Remote photographers put cameras basically everywhere, and that's what we are loving about this company so far, is their level of transparency and trust with media has just been absolutely incredible. It was so fun. A lot of the media was able to come out yesterday, set up cameras. We've been out here for a couple days setting up cameras. It's just been incredible to work with this team, and the transparency. It really shows that this team is confident and really that they're really excited about the system that they're developing. And it makes it easy for me to get excited, because obviously I believe that you get most excited when you learn something about stuff. And And frankly, you know, I've learned a lot about this rocket in the past, but coming out here and seeing it in person, getting up close and personal with it, I actually touched it. I don't think I've ever touched an orbital rocket before, like, you know, right before it's about to fly. So I'm getting a little bit spoiled out here, but it's been very, very fun for them to be able to share that with us, and for you know, making all that stuff possible. So it's just been an absolute pleasure. So here's from Alan B asking the important question. Don't forget to look in the top left of your screen. You will see that weather is currently go, and that's the latest we have heard. Is just weather is go, and we are on comms loop, so we do have the most up-to-date information possible. But wind is go. That's all we've heard lately. I think we are within another. I think within another weather update here at any second, actually, right? Yeah, T-minus 20 minutes. Is that the next weather update? So we will get one final weather briefing here as the teams get ready to go into their internal go no go poll, and then we will share with you guys the updates on that. This is from Top Secret. This is an important question. Unfortunately, we don't have telemetry wired in for this mission yet. That was just one of those things that in the future we will definitely be able to do that. But it's actually really, really hard to be able to integrate all of that in our new system and with their systems. You know, there's just some talking that we got to figure out how to make happen. But so unfortunately for this one, we're just going to be able to, you know, provide you guys tracking cameras. Once the vehicle's in orbit, we'll get some updates and even onboard cameras, hopefully, assuming everything looks good on their end. So we've got some cameras, we got some views.
Whoa,
this is a view from, this is actually Vandenberg's tracking camera. Look at that. So we've got that. We've got our own our own 4K cameras that are shooting in high speed, at least 120 frames a second. So we've got a lot of really cool footage we'll be able to provide for you of today's launch. And I'm just so excited for this. I don't know what it is about Vandenberg, but it's got a certain just feel to it. It's really cool, and the city of Lompoc is super fun. So yeah, so this is actually a great question from Jochin saying, did they ever release what went wrong with their first rocket's attempt? Yeah, we actually talked about it a good amount when I spoke with their former CEO, Tom Markusik, last year. I was actually standing with him right next to one of their Reaver engines, and he's just showing me the plug that ended up failing. There's literally a power connector that has, you know, like a twist lock power connector thing, and unfortunately, it actually rattled loose and the pin sheared, and it ended up disconnecting from the power systems on the rocket, and it shut down engine 2. So that's exactly the failure that happened. Is just a few seconds into flight, engine 2 shut down. The vehicle continued, which was actually really impressive because if you the way the rocket steers itself through gimbals, each engine can actually only gimbal on a single axis, and there's 4 Reaver engines on the first stage. Yep. So basically a pair of engines can swivel Z axis, and the other 2 can swivel on the Y axis, and that provides your control authority. But when you shut one of those down, I can't even imagine, like, if you've played Kerbal Space Program, it'd be really fun to see if we can do this with there's little Vernier engines in Kerbal. Shutting one down out of a pair would actually be really hard to maintain control. The vehicle actually ended up going supersonic despite losing one of its engines on ascent. So it's actually
there is this fact which you should know, that these rocket engines does not have like a full gimbal activity there. So these engines can only gimbal in one direction. So they uses, like, you know, work in conjunction with all those 4 engines to work in those directions. So it's like 2 engines work in one axis, the other 2 works in another axis, as he said. And so it's kind of very interesting to see like how it was able to attain its supersonic speed even after losing one engine. So if you want to see that footage, yes, it's available on YouTube. You can just go and search for that.
So they just simply moved the connector and let the wire be in that spot that was,
yes, Ignacio, congratulations and best of luck for all of the satellites and MSAT also for making a flight on this one, and all the best. Let's hope this Alpha rocket is able to do its job this time and go to space. So we are right now T-minus 18 minutes from the launch. Things are looking good. The weather is holding up. The range is green, and yes, the Firefly is looking looking great right now. It's like it's looking so good right now, and let's hope this rocket flies for the second time and makes it to the orbit.
Challenger changed all that. It's an amazing launch site. Again, it is now currently home to the Delta IV Heavy. But yeah, that's actually Challenger. And unfortunately, you know, obviously we all know what happened with Challenger. But the sad thing too is that it made them the teams reconsider the space shuttle program and reconsider the safety and the systems and all of the ground systems, everything. And basically they looked at Vandenberg and the way they're planning to fly the shuttle from here, and they basically were like, no, this is not going to work. So unfortunately, although there are pictures out there, I should probably pull up a picture or something of the space shuttle at Space Shuttle Slick 6. It is some of my favorite images in all of spaceflight history. It's just these vehicles, images of the space shuttle at Slick 6. It's so cool. I'm trying to find just a single decent image. But yeah, so here's if you just Google search Space Shuttle Slick 6. This is one of those images, and come on, how cool! That reminds me of, like, I had Lego sets of the space shuttle. For some reason, that just screams that era of my childhood. This would have been the early '80s before it got canceled. So yeah, oh man, Vandenberg. That would have been crazy to see. Because the cool thing about, you know, launching from Vandenberg, launching from the West Coast, is you do go into those polar orbits. You go north-south, you go over the poles, basically, for most launches. And no human has ever been on a polar orbit. So if the shuttle had flown, it's funny because the shuttle was the second opportunity for the U.S. to have a polar orbiting vehicle, because the Gemini program and the MOL laboratory would have been polar orbit as well. That got canceled. Space shuttle got canceled out here. So still no humans have ever gone into polar orbit. Yeah. So let's keep going here. Actually, maybe, Andrew, if you have it, actually, we're talking a lot about Vandenberg. We did have the 30th send us a cool video from the Space Launch Delta 30, who is out here with range support, supporting this mission here today, because there's a lot, you know, you got to make sure everything's good to go, that there's no range violations, even, you know, people in traffic, you know, and people on base, but even the sky, the sea, I mean, everything has to be under consideration to keep range safety clear. So we actually have a video that was sent to us from Space Launch Delta 30, and we're going to roll that here, and we can learn more a little bit about what they do.
Vandenberg Space Force Base's top priority is to assure access to space and safety for all of our launch partners, including Firefly.
All right, we are T-minus 15 minutes, and nope, it's not being stolen. It's on, I have taken the permission, so there's that crackpot. So right now we are T-minus 15 minutes from the launch. Everything is looking good. These 4 Reaver engines, as he said, has 1-axis gimbal only. So there's that, and this was like the first launch. Here, if you can spot, one of those engines actually was not working. Okay, they did not show it properly here, but yeah. So yeah, there you go.
To Vandenberg Space Force Base out here for providing support on today's mission. Pretty impressive to work alongside them, and I know that this would not be possible without them. So pretty excellent there. This is a fun little anecdote here for our audience. Again, if you're joining us, I don't know how I've been so lucky and fortunate enough to be able to provide this opportunity for you on behalf, working with Firefly. It's been amazing. But for us here at Team Everyday Astronaut, this is from Chris L. I'm impressed that Everyday Astronaut have managed to get from SLS launch in Cape Canaveral in Florida to Vandenberg, from Vandenberg from Cape Canaveral, Florida to Vandenberg, California. Even Google can't calculate the distance. It's very far. Ryan and I, from Cosmic Perspective, drove it in basically 3 full days, and then we had 2 little, we had kind of like a little half-day situation. But we knocked it out of the park, driving an old news van across the country. That's how we're able to provide you guys this feed. It was quite the journey, but yeah, it's definitely worth it, because here we are looking at a vehicle that is looking good to launch. So yeah, let's see here. This is a good question from Jonathan. Will you be able to see this from Los Angeles? Because it's a day launch, and it's a relatively small vehicle, there's no solid rocket booster, so it's not going to be leaving a big condensation trail behind it. I would say no. If you knew exactly where to look, and you had really good eyes, and maybe you just knew exactly which direction to look, you might be able to catch it. You might, but because it is actually flying kind of southwest. But even daytime launches flying straight south are relatively hard to catch from Los Angeles. Nighttime's a different story. If this was night, I think it'd be quite a bit easier, but that is not the case. It is full-blown, bright blue skies, bright daylight out here. So, yeah, I kind of doubt you'll be able to see it from California, or from Los Angeles, but I think you should try. I think you should try. Thank you so much from that taco guy for the gas money. We really appreciate that. From Ben Glasgow wants to know, if I were a rocket, what rocket would I be and why? Well, rockets are meant to fly, so I think, if I had to be a rocket right now, it'd be this rocket because it's right about to fly. Why would you choose anything else right now? This is a really exciting rocket that's right about to take off, so I'd want my first opportunity to fly. So I'd be Firefly's Alpha rocket and carbon composite, and I want to be the first in something.
So it's not at my end. The EDA stream has had some issue here. Well, let me just see if I can correct it. Just wait a second, guys. Not at my... Yep, it's the... People are saying FFF in its comment
A really exciting rocket that's right about to take off. So I'd want my first opportunity to fly. So I'd be Firefly's Alpha rocket, carbon composite. I want to be the first in something.
All right, I think they are back again. Yep. Well, just... See, these hassles you don't need to worry about when you are with me, when you are on this channel. So there you go.
I feel like this is an appropriate question. How is the internet in the Luna van? Is it fiber? Yeah, it is. It is fiber. We're literally piped into, I think, about the best internet you can have. And even despite that, sometimes things get ornery. We don't exactly know what that technical issue is. Again, we had been on support with some teams from our encoder in order to see what that issue was. And we don't know why that happens. We didn't lose any data up in the cloud, so it's actually a handoff from Teradek to YouTube. That's the issue. I actually have this little chart right here. It shows perfect data going up into the cloud. So hopefully we get that figured out here at some point. We do have an update that prop load is complete. So we are waiting. Our next milestone that we're waiting for at this point is to hear confirmation of a good go, no-go poll so we can give you guys any updates. We'll give you any updates that we have about the status of today's launch. Obviously that's what we're here for. So let's see. Again, I feel like I should answer this one more time. Just what is the launch visibility like on the West Coast? You likely will not be able to see it, too far away. If you're too far away from Vandenberg area, from Lompoc, you won't be able to. You probably won't be able to see it too far away. It is a relatively small vehicle. Can we actually pull up the specs of the rocket on the side of the screen at some point? Because it would be kind of fun to talk about the size and stuff like that. So actually we have that. Yeah, look at that. How cool is this? So it's almost 30 meters tall, about 30 meters tall, 95 feet tall.
So
this is actually
is launching from Vandenberg Station, Air Station.
This is actually a very large small sat vehicle. It's coming up almost on some medium class vehicle sizes. Diameter is 1.8 meters, so 6 feet wide. So if you're like, I'm just under 6 foot tall, I could walk straight down the fuselage of this vehicle. It's again quite large actually. The propellant for this vehicle is LOX and RP1, so we sometimes we'll call that Kerolox, so kerosene and liquid oxygen. That's what this vehicle uses on both stages. Then there's 4 Reaver engines on the first stage of this vehicle and 1 Lightning engine powering the upper stage, which is also tap-off. So this company's diving deep into the tap-off cycle, which again I think is super cool, and I just can't wait to see it fly. So I didn't quite catch what they're saying on comms. Do we have any updates here? Confirm. I can hear it, but I can't talk and hear at the same time. I'm not that talented. So let's see. This is a good question here. This is something that the range gets to deal with. Being a new rocket, is there a bigger radius than normal around the pad that's closed off in case something goes wrong to avoid injuring anybody?
T-minus 8 minutes and 20 seconds. Fuel pre-press will be beginning shortly.
Fuel pre-press will be beginning shortly. So, yeah, I heard that. That's exciting. Fuel pre-press will be beginning shortly. That means the vehicle is topped off, and they're basically going to begin pressurizing the rocket to be able to, be ready for flight status. So you do have to pressurize the tanks up to operational pressure. So But yeah, back to this question. The good thing is, you know, the range gets to clear off Vandenberg Space Force Base.
Oh, look at that. It's kind of an engine chill which is happening right now.
It's relatively easy because it's a control.
So it's no genre. That is not the case. They are flying some payloads here. No, it's not like a no payload. We are having quite a number of payloads now from NASA, from Teachers in Space, Libre Space Foundation, AMSAT, FOSSAS also. I think FOSSA. That is that. So we are having some payloads around 35 kilograms of payload, but still it is in testing. So those payloads are not like, you know, those paid one. Mostly all of them are, I think except NASA, all of them are unpaid. So there's that.
Let's see. I'm kind of getting some updates here, so I'm really excited because things are looking good. I just want to confirm to our teams that we have cameras rolling and things. We're going to be ready to go on our high.
So T-minus 7 minutes from the launch, things are looking good right now. You can literally see the tanks pre-press, which simply means they were trying to pressurize the tanks for the engine, for the flight parameters, so that they can have a proper tank pressure check. And also the engine chill. Right now you can see those clouds beneath the rocket. That is kind of, you can say, engine chill. The fuel is running through the engine so that it can be chilled down, and that's why some vapors are coming out of it.
On a first dev flight, you know, we're a little bit more like breadboard style, where you have easy access to things and they're easy to you know work on if there's, you know, a leak or something like that. Things are just relatively easy on the very first rocket, and they were able to clean some of that stuff up on the second rocket already. So those are some of the things that they were able to fix and just kind of clean up. But hardware-wise, it's virtually the same. They just made some small tweaks here and there, but yeah, that shows the confidence of the design and the system overall.
Strong back retract will be at T-minus 530.
So we are about to see the strong back retract in about 20 seconds. So that's the thing holding onto the rocket, the thing that takes the rocket from horizontal to vertical, and it has the clamps holding onto it, it has the umbilical systems. We're going to be looking here and observing here in about 5 seconds, looking for that to recline just a little bit.
So guys, it's happening T-minus 5 minutes from the launch, and yes, we are not having any delay or scrub or technical fault here, so that's a very, very good sign of this rocket. And there you go.
That is amazing. So yeah, that's a good sign, my friends. That is a very good sign. So now is reclining into its go position, and as you know, then
please begin final checks. No for the T-minus 2 minute call. Any no-go at this time will be an automatic abort.
Okay, so they are, guys, they're going for it. They're T-minus 5 minutes.
T-minus 5 minutes. Strongback is in launch position.
Strongback is in launch position. We have confirmation of that. That is looking fantastic.
And you can see it's more of and very similar to SpaceX tech. SpaceX also has this strong back retract and those clamps also, you know, because most of and many of the SpaceX engineers work in Firefly. Even, as I said, Tom Mueller, who worked on the Falcon 9 engines, also worked on the Firefly River engines.
Range for no-go call at T-minus
and
2 minutes.
They're literally on track to launch at the opening window of their second launch attempt ever. This is incredible. How can they have this kind of timeline management already for such a new startup company and a new vehicle? I mean, this is stuff that you only see companies that have been launching for decades be able to receive this kind of cadence and this kind of. This is really impressive. I'm not saying that to butter anybody up, I promise. This is genuinely just
4 minutes.
me impressed.
Confirmed FTRs are active and range is transmitting check channel 4.
Confirmed. FTRs are active and transmitting check channel.
-4 minutes, guys.
FTS, send ARM enable 1 command to all ESADs.
ARM 1 sent.
FTS, send ARM enable 2 command to all ESADs.
ARM 2 sent.
FTS, confirm that all ESADs are enabled.
FTS confirms all ESADs are enabled. Fly safe.
You heard it there, guys. FTS is enabled, so flight termination system is enabled. They are going for launch. We need to do one more thing here at Everyday Astronaut. We have a little tradition.
From your monitoring fuel bleed.
We need to check that the pointy end is up and the flamey end is down. Let me tell you guys, I've had a good amount of time around this vehicle. I can confirm from our end that the pointy end is up and the flamey end is down. So that's confirmation from me. There's the pointy end, and there's the flamey end. Boom. Pointy end up, flamey end down. from our end,
Well, boom
us
is
casual
not
observers,
the
this
thing
thing
which
looks
wanna
good to
hear.
go. You can see
3 minutes. Fuel bleed is starting.
When
fuel
this-
bleed, so you can see
Okay.
the engines getting ready to cool down to be able to.
Go, no go at T-minus 2 minutes. Any no go at this time is an automatic abort.
This is prop. I can confirm flow and fuel bleed.
Copy, thank you. I believe we hold this for 90 seconds.
This is happening, guys.
Vehicle will de-energize.
Whoa. Okay, T-minus 2 minutes and 30 seconds remaining. Everything is looking good. Although we'll need to hear if any go.
T-minus 2 minutes. This is the final commit for launch.
Oh, this is happening, guys. Finally, I'm so impressed that they did not
This
have
is a
any
very big thing here. That
Started.
T-minus
Scrub or
2 minute poll.
delay.
Chief engineer,
Send it.
launch director.
Go for launch.
Oh, it's happening, guys.
12.21 confirmed by
We are go for the launch.
T-minus 1 minute and 50 seconds.
It's happening. Okay. Firefly
I can't believe this.
is
They're
all
going
ready to
for it
go
already.
launch.
Like, how are they doing this? I mean,
exactly.
we are T-minus 1 minute 30 seconds. We're looking go for launch.
T-minus
I
130.
can't believe this.
Okay, guys. T-minus 1 minute 30 seconds remaining.
Trying to do a little extra bonus cam action here for us.
The engine is chilling down. You can see that. And oh, it's happening. You might get some amazing view of this engine cam as well as the flame trench cam. Let's see. And it will take some time to, you know, revive to the full thrust.
We have these two PHSs at 1700 psi.
Abort, abort, abort.
Okay, so
You heard it, guys.
hmm,
We have an abort. We will stand by for more information on why that was.
it's not a good thing. I mean, obviously it was. They were like, you know,
Taking
going
abort
at
actions at this time.
So they do have a 4-hour launch window here today,
Yep.
so don't call it
Confirm there are
yet.
no fires on video. Confirmed. GC, please stop. Please close NV 598599 Alpha Bravo. BC, confirm the following pre-valves are closed.
Confirm prevals are closed.
Helium bubble is active.
Bubble is active.
S1 fuel tank is maintaining between 30 and 36 psia.
Confirmed.
Verify all other tanks are vented.
Confirmed.
GC, please verify the T-tap tank is vented.
T-tip tank is not there. Confirmed.
Is it below 100? We'll keep.
T-tip.
Go ahead.
so guys,
Please open TV 604.
although they have like a 4-hour launch window, but the abort actually happened very deep into the countdown. And as they said, the final commit was like at 2 minutes. So after that, if anything happens, it means a big technical fault. So we'll have to wait and see if they can recycle it and again go for the launch. But most of the time this happens when they are in this deep into a countdown. We don't get a recycle, we'll get a scrub. They do the technical thing, whatever was the fault, and then go again, because this deep
So you guys are hearing
things are
there,
not
we
looking
are-
good. But let's see if they can resolve it right
You
now.
guys have heard that they have gone for they've called an abort, but again, they have a 4-hour launch window here. So that was right at the top, right exactly at the top of their launch window. They called an abort, and actually, you know, again, this is only their second launch attempt ever. So you know, there's a chance they have an opportunity to reset, and hopefully we still have a chance to fly today. We will await a new T0 time here for you guys. And we will get you guys updated on that as soon as we know anything. But currently, we are back in a hold, which means our teams here get a chance to breathe a sigh of relief, because we are definitely running the scramble game. But yeah, holy cow! I thought, oh man, my heart was racing. My heart was absolutely racing. So well, this is an opportunity. This is what's fun about these kind of streams, is that we get to tell you guys, we get to chat and hang out, because after all, spaceflight is a bit of a spectator sport for some of us here. We get to enjoy rocket launches, talk spaceflight history, talk aerospace, talk rocket science. and I get to kill time with my friends here as we learn what exactly is going to be happening here. So. Yeah, again, we are just awaiting more information and what's going to happen today in today's 4-hour launch window. So again, thank you all. If you are watching, please continue to watch because hopefully we'll learn more about today's launch attempt. See if there's another opportunity in this window. But also, you guys, this is a really exciting opportunity for this launch company. And I know it means the world. They literally have. So many employees have come up to me and just said how excited they are to be able to share this with people and how much it means that people are watching the hard work that they get to do. I mean, I know I'm just simply a conduit to be able to provide this stuff to you guys. But really, you guys watching and cheering for this company just really means the world to everyone working on this vehicle. I've just had the opportunity and the pleasure of meeting so many people, and they all say that they're so excited that we get to share this with the world. So let's hear it. Just give a hand for them for aiming for minute like T0 right at the top of their launch window. A date that they've had in the books for months. That's impressive. That's genuinely impressive. So, yeah, thank you again to everyone for watching. Hopefully we learn more and more here, and we'll update you guys as soon as we can. But meanwhile, we want to give you guys a few extra questions here. So this is from Budarowski saying, Tim, what's the difference between the Firefly Alpha, Beta, and the new Antares first stage? Thank you, Tim. So right now, the Alpha is the only rocket that they're flying at the moment. This is their first rocket. This is their opportunity to learn a lot on a little bit smaller scale. The Beta rocket will be a lot larger, and its first stage is virtually the same, at least at first, as Antares, and it uses much bigger tap-off cycle engines called Miranda engines, and so it's going to be a much larger vehicle, much more powerful. So it doesn't even share the same exact engines, but it does share the same engine technology, being that it is tap off. So yeah, so I don't know yet if we're gonna see it first on Antares or if we're gonna see it first as the Beta rocket. I don't know. I'll try to learn about that because that's gonna be really exciting. I mean, seeing how developed this system is already for its first attempts is awesome, so I can't wait to see them scale up and continue doing big things. But the cool thing is they definitely are wanting to fly this rocket and continue flying it alongside of even larger rockets because there is a demand for this larger, for this small sat rockets, but having a little bit more capability means they can fly, larger small sats and even be able to use them in tandem where we can literally launch like say 2 or something and still have a dedicated ride to very unique and particular orbits. That is a capability that ride sharing can't do. So they think there's a nice niche there. A lot of people think there's a nice niche there. There's a lot of upcoming rocket companies working on this exact market.
But
So they think
it might
by all
be
accounts, they'll
aborted
continue
due to
flying Alpha
weather.
even when Beta's flying,
And next
even as they
attempt
continue to
at
support
4:06 p.m.
Antares as well.
Pacific. So we'll have
Are
to
there
wait and
cameras,
see.
onboard
But
cameras
that's
on
what
this rocket? Yes,
mm,
there are.
my
There are
sources
cameras
tell.
on
But
board the
let's see.
rocket.
Let's see. Let's have an official
And
confirmation.
yeah, that's something that's obviously pretty cool. We aren't able to show all of them, but we can show some of them, and at particular times we'll be able to do exactly that. So, yeah. This is from Corey S. Thank you so much. I appreciate your chat saying, welcome to Cali, Tim and crew, pointy end up, flamey end down. It's so fun seeing that we actually have the cameras out here to really give you a good confirmation. Yeah, how cool is that? Let's see. Yeah, thank you so much, Mike Jennett. This great broadcast, Tim. Big shout out to Firefly team for all the hard work at Astra. 100%. Again, space is not easy, and we're seeing them knock it out of the park so far, just even getting this vehicle on the pad and fueled up and going for a launch attempt this early on. Very, very impressive. This is cool. I love seeing these kind of comments. This is from, I'm going to totally not say this name correctly, but
we have a hold right now still, though I'm trying to search what is the official reason for the hold. Not so sure about that right now because we haven't had a official source, but still that's what I've heard. So about it due to weather, but we'll see if it is due to weather. Then we can expect a launch today. Because if I remember correctly, last time also the Firefly had an abort due to some deep into the countdown only, and then they had a recycle in about an hour, and then they flew the rocket. Although one of those engine was not able to, the power connector was disconnected, and that's why it was shut down. But still, they were able to fly it. So not so sure about it, but they might be able to recycle it again. And what I'm hearing is 4:06 p.m. Pacific is the next um, uh, launch time they are aiming for. So we'll have to wait and see.
So insanely brilliant, I can't even comprehend. And to be able to problem solve and make it so you can put things into orbit, just simply crazy. So, yep, it's my pleasure. I love hearing that people are out there, looking for and working on degrees in aerospace engineering and things like that. Really makes me smile. So thank you for saying that. Yeah. So this is actually really cool, Thomas. This is a fun little thing. You'll see on the screen right now is an A for Alpha. The next letter next to it, there's an L. Then there's a P. Then there's an H on the four things. And if you keep going, it goes back to A. So it actually, if you go around the rocket, it actually says Alpha on the four engine covers there. Fun little Easter egg. I think that's super cool. Which I just think is awesome. So the teams have had a lot of fun with that as well. So yeah. Let's get to a few more. Again, thank you for those of you that are, super chatting and doing members. I really appreciate that stuff. That really helps us here at Everyday Astronaut be able to provide you guys this kind of coverage. And thanks again to the teams at Firefly for trusting us. I'm going to try to keep things a little bit more on topic-ish since this is Firefly's live stream. But just know from the bottom of my heart, it really means a lot that you guys are tuning in. And the support goes a long ways and makes this stuff possible. Because, yeah, it's gas prices these days, driving across the country is definitely expensive. So it's just this is an opportunity that we absolutely could not pass up, though, to be able to put cameras on a launch pad with a rocket on it that's about to take off. I mean, 4K, come on. It just doesn't get better than this. So you have to do it, right? Let's see here. This is a good question. This is a little bit topical here, but we'll take it anyway. From Troy Hammond, thank you so much, saying, "Hey Tim, are you planning to head back to Florida to cover Artemis again?" Yeah, we definitely want to. We definitely want to. Obviously the Artemis program and the SLS rocket is incredibly exciting. It's the most powerful rocket on a launch pad, I guess, ready for flight. I'll put it that way. I don't want to start a flame war here about what's the most powerful rocket, but we'll say it's the most powerful rocket that's ready to fly-ish. But I can't wait. I cannot wait to see that rocket. You guys know that we've worked really hard to provide coverage for the first couple of launch attempts of Artemis. As soon as we know more, the teams at NASA are working through some issues to see if they can fix some of the leaks in the system, and I think they're going to be testing that like the 17th and or the 18th or something like that, and they're go for another opportunity to fly, I believe starting the 23rd. So there's a small chance this van will be going right straight back to Florida. Personally, and that was a selfish thing, I hope that it scrubs until the next launch opportunity in October, so we can have a little bit of downtime and not just be a full-time like touring van thing. As much as it was fun to be on the road and get out here in a real hurry, that still was definitely pushing timelines. So this is from James Anderson. Do they shut off the liquid oxygen vents prior to launch? If so, how much time do they have till the tank's over pressure? So you'll notice that on rocket launches, those vents are always active and they're regulating the pressure, because even as they begin to drain the tanks, and as they're being backfilled by helium, or in some rockets, autogenous pressurization, so still using gaseous oxygen or gaseous methane or gaseous helium to backfill the tanks, you still need to maintain proper tank pressure. So sometimes you will see venting, and actually watch slow-mo videos of rockets. You'll almost always still see venting coming out of vent port on ascent. So that's quite normal, and it's just a way to maintain it and continue to have the pressures be perfect. I don't know if any of them would ever totally close entirely. Because
I have heard about Firefly, and I was actually searching for Firefly only to watch it. I didn't find it on any streaming platform. I'll make a deep search, but yes, I'll have to watch. This is in my list, in my bucket list. So yeah, right now I'm watching Better Call Saul, but yeah, that's on my list for sure.
Work on the vehicle and get this thing ready to fly, get this whole system put together. And again, seeing their facilities out there in Austin, Texas. Both their main campus is incredible, where the engineering happens and their mission control and things like that. But Briggs is where, so in a previous life I used to work on cars and motorcycles a ton. And going out and seeing Briggs where they're building and testing, like these are people in like machine shops just getting their hands dirty, literally working on space flight things, you know. And I think a lot of the people, I've talked to different people that a lot of them did come from like the automobile industry, come from racing and things like that, having racing backgrounds that went from precision manufacturing, precision tooling, and precision mechanic work from cars and high performance vehicles to even the most, in my opinion, this is about as high performance as you get. A vehicle with thousands of horsepower. I mean, come on. This is about as cool as it gets. I get the bug when I walk through a factory like that and I walk through a machine shop like that. I get the bug. I want to tinker. I want to help build and things like that. I got to say it's very inspiring. If you are someone looking for a job, this is not they're not telling me to say this. I promise. This is just me. I would go out there and I'd be looking in LinkedIn for some positions. I know that Firefly's got some positions available. If you're looking for a job, I think these guys are hiring. They've got a lot of really impressive things on the horizon. I mean, they're going to the moon. I don't know if you guys know this. They're literally landing a lunar lander in about 18 months with NASA. It's actually riding on a Falcon 9. It's their Blue Ghost vehicle. Super cool. I had the opportunity to speak with Shay the other day, who told me a little bit about that. I have a video that we'll hopefully be able to post here in a little bit. We ended up having so much time setting up this live stream that we haven't had an opportunity to post the video yet. But I got to speak to a couple people and learn more about some of the things they're working on. They're working on really hilariously big things. Like, this is a company that I think a lot of people kind of went under the radar. And then all of a sudden, the last, like, 6 months, it's like, holy cow, these are some really big and exciting things. Yeah, just a little shout out. I'm just excited. Let's see. This is, okay, cool. Randy Wiedenfeld says, just got the metal Falcon 9 that we have in our web store. Thank you so much, Randy, for your support and your patience. I love seeing these shipping out. That makes me so happy. How soon will we get more? I would love a smaller rocket for true size comparisons. So, yeah, so we have 1/100 scale model rockets that we did our first run of. After some manufacturing woes, we got new parts in, and they are shipping to customers. I've been seeing a handful on Twitter. It's so cool to see these in customers' hands. And that's the first of hopefully just a whole fleet of rockets. The biggest point for me is I wanted them to all be the same scale. It's so weird to me, like the common scales for model rockets is like 172 and like 177, all these weird scales. It's like, no, make it 1/100th, and I want all vehicles to match the same scale. So that being said, I decided that that's exactly what we're going to be doing. So the Falcon 9 was our first rocket that we put on in the store and made. Hopefully next, I really would love to do some small sat launchers. I mean, seeing Firefly's Alpha next to some other rockets and other small sat launchers like Astra's rockets and the Electron, Rocket Lab's Electron and Launcher, all these exciting new rocket companies. It'd be really fun to see them in size comparison because there's a whole, I mean, you could basically make a perfect gradient of size of all the vehicles that are out there today. They come in all shapes and sizes, and it's really fun. So that is the goal someday, just have this huge collection that we can get out there for people to be able to pick out their favorite rockets. And yeah, and again, seeing this vehicle out on the pad, compared to the Delta II was a very small medium lift launcher. It was right at the bottom end of the medium lift launch capability. Half the time it flew like small sat payloads, basically. But it's been fun because that's the only other vehicle I've ever seen out here on the West Coast. And this rocket is, frankly, a lot closer in size compared to that than a lot of other small sat launchers. It's a very, very large rocket. Again, maybe we'll take this opportunity. Can we throw up those graphics again? Because I do want to remind people of how big this thing is. It is about 30 meters tall, so quite large in this small sat game. 1.8 meters wide, so 6 feet wide, and that's a big rocket actually for a small sat launcher, which is why it has such high performance as well. So this I like seeing this from L Motorsport fan saying, how meta is it that I'm sitting here working on designs for a satellite bus while watching this live stream? Thanks for the amazing coverage. That is, I love that. Again, it's just so cool that we have this generation of people that are watching this stuff in real time, casually in their living room. We're getting we're getting shots like this. We're getting footage from all over the place from a ton of really exciting things about rocket launches that we just didn't have this kind of access previously. So it's so cool that this is becoming a bit of a spectator thing, that people are joining in and getting excited about this stuff. So, all right. Let's see. This is T. Burns wants to know, what's the purpose of Firefly anyway? This is the first time I've heard about it. Well, there's a race, my friend. There is a race to fulfill the needs of customers. There's so many new startup companies that have payloads that are trying to get to orbit. I mean, there is literally like a laundry list, a backlog of countless payloads that are trying to get to space, because a lot of people have new ideas, new demonstrations, new ways to communicate, new ways to observe, new ways to look at the planet and study things like climate change and weather and track hurricanes. I mean, I can't even tell you how many people are out there literally working on satellites that are still trying to find a way to get to space as quickly as possible and as cheaply as possible. So the race is on still for a new crop of payload payload services. So that's exactly, Firefly is positioning themselves to be a staple in the launch industry. So, basically think about it here in the U.S., the most common, there's USPS, the Postal Service will deliver your packages, but there's also, of course, FedEx, and there's UPS. Globally, there's a handful of companies that deliver a package to a destination, and they're competitive with each other, and you have multiple solutions. There isn't just one out there, and that's the exact same thing. These things, there's payloads that need to go to space, and people pay someone to get them there. They're the UPS truck, they're the big brown truck getting things into space, and the race is on right now to be the first to be able to provide those services. So, yeah, Firefly can certainly fulfill those services for a huge crop of vehicles. So, yeah, super cool. Let's see here. I'm actually going to probably take a little bit of a break while we wait for an update here from the teams. We're going to leave you with the rocket on the pad here for just a little bit. But I hope I'll have a lot more time. We do have a 4-hour launch window to be able to get you guys. Hopefully we see a launch today, because the sky this is amazing. This is the nicest day we've had out here. So we're really hoping that we do have the opportunity to see a launch today. So stand by as we get more information here from the teams. But I'm going to take just a quick little fiver, but we'll leave you guys with beautiful views of this rocket in stunning 4K. We'll be right back.
All right, so there you go, guys. We had an opportunity to make sure this rocket, but okay, so there is an official update kind of a thing, whatever you want to say. We aborted at the top of our launch window. We have an 4-hour launch window today, and we'll work on the issue to see if we can recycle. Okay, so there was an issue. More updates coming soon. So still not sure what issue those were. So I don't think so. We had an issue of weather, but still we'll have to wait and see. As they said, they have like a 4-hour launch window, so they have plenty of time. And let me remind you, similar sort of thing happened during the first launch attempt also. They had to abort very deep into the countdown, and then they recycled it after 1 hour and then launched it, although that was not a success. Hopefully that does not happen today. Today they have a success, but yeah, there you go. We'll have to wait and see for the next update. So hey Yehuda, welcome to the stream, welcome back. Are they ever going to make this rocket reusable? So right now, let me just tell you guys, the reusability thing in a mind is a very challenging thing for any new rocket company. Okay, so if any new rocket company comes into existence, then they don't look into reusability. First of all, what they do is they first of all make sure that the payload reaches the orbit. Okay, so that's what happened with the Falcon 9 rocket. The Falcon 1 was launched so that this rocket can go into the low Earth orbit, and then they moved on to the Falcon 9. Falcon 9 also had like many failures before it could reuse, but that rocket was made possible because the mentor was Elon. Okay, so reusability is a thing which is very hard to do for a new rocket company. So there's that, but that does not mean nobody can try it. Obviously, people can try it, but with the small sat launcher, that becomes harder to do because they already have like a so little wiggle room to play with. If they also have attached a reusability tech to it, it will result into payload penalty, and obviously the small sat launchers can't afford it. So that's why they need to redesign their reusability technology, and that's where the Electron comes into place. The Electron rocket is reusable now. They are trying to make it reusable by not having a reusability tech that SpaceX uses, the entry burn and then the landing burn, the payload deploy, the legs deploy, and then uh, landing onto the drone ship. Nope. There won't be any entry burn, so it will just go straight into the atmosphere. Then there will be then that payload, that the first stage of the Electron rocket will be saved using a parachute and then caught up with the helicopter. So it's a very different strategy which they will do. But yes, the small set launcher, since those launchers are small in size, so therefore they can use and they can take the advantage of the parachutes, and that's what Electron is trying to do. So talking about this, yes, they can go into reusability because this rocket especially has a very good payload capacity of around 1.1 tons to low Earth orbit. So yes, they have a lot of wiggle room to play around with, but still they are not planning to do it right now. Nothing that is not in the plans, but as the business progresses and as the demand increases, they might think over it, because for the Electron also that was not the case. The reusability was not in the plans at all. But since the demand of the Electron rocket was so high, they were not able to fulfill it, and that's why they wanted to reuse the rocket which they were flying previously. And the reason why they are reusing the Electron rocket is that only because they want to make sure that that Electron can be made available to the customer at a very fast rate, and they don't need to manufacture a whole new rocket. And let me just tell you, it is not economically viable for them also. Like Electron is like already way too costlier. $7 million per launch for a small set launcher is way too costly. But still, they are trying their best, and reusing an Electron rocket is kind of burning holes in the pocket only. But in the long term, it will give them profit. So there's that. So right now, yep, to answer your question, they don't have any reusability planned, but as the time progresses and as the demand increase, they might look into it. Or we can't say for sure. I hope that answer your question. Okay, let's hear some till then. UT 0420 PM PST. Okay, let me just update that here. So, Yoda, they are trying to launch it again. As I said, as they said also, the new T0 is at 420 PST. And let me just update that here also. So they are looking in for the launch still, but we'll have to wait and see if that happens, because still they're trying to resolve the issue and see what actually went wrong, because at that deep in the countdown, it's a very crucial system which did not respond properly. So they'll have to wait and see if there was a faulty sensor or some sort of issue which can just be solved by restarting the system. So yep, restarting the system actually does help, and it's kind of a meme and it's kind of a joke that if anything does not work, just turn it off and bring it back on again. But it's a thing, it's a valid and scientific thing. When you turn off a system and turn it back on, it resets the system. So if there is any software program which went into a infinite loop, or which was stuck at a certain interrupt, then that resetting the system actually helps, because it starts that computer execution from the very beginning again. And so yeah, it just bypasses that kind of, you can say, not bypass, but I would say it just resolves that issue. So, and that is just a software terminology, but that is also true for mechanical things. So we'll have to wait and see what they come up with. But we don't even know whether there's any issue which is solvable or not. But they have given a new T0, so we can say it is solvable, and they're right now looking good at that window. So there's that, and you can also see that launch clamps are back into place. The strong back is also back into place, so that it is able to hold the rocket in place before it lifts off. So yep, there you go. It's not only this strong back. You might be thinking that it's there to hold the rocket in one place. Yes, it has one of those thing which has to do, but other thing, it also provides those power, electrical system, the fueling system, the communication and whatnot. So those are also things which are provided by strong back. So and obviously the strong back retract happens at a certain point of time in a timeline, the countdown timeline, and if they are going in at a recycle which is beyond that timeline, beyond that time, so then they need to make sure that the strong back is also in that position so that they can deploy it again, right? So that's why it is holding the rocket right now, making sure it stays in place and just does not wiggle around, right? All right, so T minus 50 minutes more or less left for the launch. We don't know for sure actually what happened, what went wrong, so we'll have to wait and see. But yeah, things are looking good right now. Nope, we don't have any other update yet. So if I get to have any other update, I'll surely tell you, but right now, nope, no update. So we'll have to wait and see. So just right now listen to the tunes. I hope that would help, and we'll be back again if I have any other update.
am back, ladies and gentlemen. And if those of you that didn't read the little thing where my face now is, if you couldn't tell, and if you haven't checked our T0 time, we do have a new T0 time. So the teams are going for another launch attempt in today's 4-hour launch window. So the local T0 time is actually 4:20 Pacific Daylight Time PM, which is 42 minutes, and I'm going to wait for it. And 42 seconds from this exact moment. Lots of 4s and 2s. Mary Liz Bender's going to be very happy. Anyone else that's a fan of Hitchhiker's Guide to the Galaxy, that's got to make you happy. So yeah, we're 42 minutes away from the next launch opportunity of Firefly Alpha. Look at again, take a moment to just gander at how beautiful the sky is. I really hope this thing takes off. And the later in the day we get here, the more beautiful that blue sky gets. I think, the rocket just might, we don't actually have any official word yet on what caused the scrub, but, they're getting quite close in the terminal count. So as soon as we have information on what caused that scrub, we will update you guys. But the good thing is, maybe it was just the rocket wanting to put on a better show and be in prettier light. That's at least the photographer and me speaking. That's probably exactly what it is, at least on my end. So, how have you guys been? I hope you guys didn't miss me too much. We shifted some stuff around here because the sun is starting to get lower and lower out here in California. So we're starting to get more and more heavily shaded. Or I wanted to make sure I was in the shade, not getting too sunburned. All right, so let's go ahead and answer a few more of your guys' questions here. Let's see. So yeah, as you see too in our little prompt here, after the first abort here, which was 38 minutes ago, the teams have been able to get another new T0 time for another launch attempt at 4:20. So really exciting. It gives that gives me a sigh of relief, honestly, because I feel like it came up out of nowhere for us. Like I feel like we were all ready to go, and all of a sudden we're in the last 3 minutes, and I'm like, oh my god, I don't know if I'm just ready for this. This is good for me. I don't know if they did it for me, and again the lighting. I don't know. I'll stop talking. Let's see here. Let's look through a few more. Let's see. I don't really want to get into too much speculation here from people, so actually, I have a fun thing. We did have a lot of questions, and I've realized, honestly, the best way to answer some of these questions about this vehicle is to actually just go to a little website. I do this trick a lot. A little website, but this time it's not everydayastronaut.com. This time it's firefly.com, and clicking on their alpha link. Their website's amazing, but they actually look at this. They even have a way to be able to see the inside of their engine, of their rocket and stuff like that. So I actually forgot the payload of this vehicle. The payload capability is over a metric ton, 1,170 kilograms. Like I said, this is at the upper end of a small sat launch vehicle. That's like getting awfully close to medium class. Which please remind me, chat, or if anyone has information. I forget what where that officially starts. I don't remember if it's 2,000, 2,500, or what it is to get into medium class. Or maybe it's 4,000. I don't actually recall off the top of my head. But that's definitely in the upper end of the small sat launchers, especially in this new crop. And that's on a 28.5 degree inclination. So that'd be like if you're launching from Kennedy Space Center, that's how much performance it'd have. If you're launching to SSO, so Sun Synchronous Orbit, or a polar orbit, that does decrease to 745. That's normal for all rockets to take a performance hit when they're not flying, straight due east. They're not taking into account the full rotation of the Earth. And like we said, today's mission is actually flying retrograde. So it's actually flying beyond SSO, so backwards, dude, in relation to the rotation of the Earth. So that's 745 kilograms. Again, today's flight has about 35 kilograms on board, so you can tell they're definitely not putting a ton of payload onto this vehicle for its inaugural orbital flight. So yeah, again, this website is amazing. I can't recommend if you want these stats on this vehicle. And again, 322 seconds of specific impulse in a vacuum is pretty impressive for a tap-off engine. So yeah, and same with almost 300 for the Reaver. So that extra expansion ratio, the longer nozzle on the Lightning engine in the upper stage, does allow it to be a little bit more efficient in the vacuum of space. Pretty cool. So yeah, that's, again, shout out to that website, firefly.com, and then click on alpha or /alpha. You can get all those things that you've been asking me about, and hopefully that helps. That's a good reminder for me. 1170 is its payload capability. Again, pretty impressive. So All right. Yeah. So again, we're basically at this point just awaiting more information, and hopefully we receive an update from the teams here relatively soon, and that will give us some information on. You know, maybe we won't receive an update on why exactly they scrubbed, but the important thing, the most important thing to me, is that they're go for another attempt here in 37 minutes. So yeah, this is again, thanks to all of you that have become members, that have you know, just helped with today and asking really good questions. We'll take to air whatever we can with your comments and stuff like that too. So thanks to all of you who make that possible. I gotta say thanks to people like 55 Chevy Guy _ Steve. Thanks for the great coverage and informative videos. You are so welcome. Again, this is absolutely not a one-person job anymore. This has turned into a whole team of people that are helping provide this coverage. So it's just I'm so thankful to have people working so hard along with me that make this stuff possible. And yeah, our team for this mission in particular, and also for the Artemis launch attempts, it's just huge. It's a whole crew of people. It's so funny. I never thought I'd be borderline running like a production company, but here we are. Here we are doing basically exactly that with some state-of-the-art equipment. Again, we've got some awesome cameras out here on base. A lot of 4K, you know, obviously the 4K pad cameras that are also going to be recording some slow-mo footage for you guys, but we also have some awesome tracking equipment here. We'll be able to provide you guys with clean feeds of the ascent of this Alpha rocket. It's going to be super fun. As soon as that thing comes up over the mountain, it's going to be quite the shot. You can basically only see our bright orange tent there in that shot, but you get the idea that we are here with lots bright orange. That's pretty obvious where the Everyday Astronaut team is when you see bright orange. So, all right, let's see. This is from. We do have confirmation that weather is go for this new cycle too. So the teams have been tracking weather a little bit. There's been some iffy weather, dodgy weather potential for cloud violations and things like that. Because don't forget, there's actually there's actually a hurricane that was just recently off the coast of southern coast of California, and there is some weather that's different and unusual around here. So they're definitely having to track that. And, you know, they need to have good visual tracking for this rocket, so we're lucky enough to have really blue skies right here today. It's really, really quite exciting. Yeah, so let's see here. Let's keep answering a few more of you guys' questions. And again, thank you to people like Jerwa that just became a member. Really, really appreciate that. Let's see. So this is a good question, actually, from Gerardo Neva. Thank you so much again for your generous donation as well. Why are these newer rockets more powerful but less impressive at launch than the space shuttle, for example? So far, I'm trying to think. I don't think I've ever seen a rocket that's more powerful than the space shuttle. If that helps answer your question, because the statement was, why are these newer rockets more powerful but less impressive? I have not seen a rocket fly that's more powerful than the space shuttle yet. And SLS likely will be the first rocket that I see fly that is more powerful than the space shuttle, because it has an extra, about 25% more thrust out of its solid rocket boosters, and it has 4 RS-25 main engines on its core stage as opposed to 3. So it is basically just a more powerful version of the space shuttle. But Falcon 9, much less powerful than the space shuttle. Falcon Heavy is I can't remember right off the top of my head what that was. Can you repeat that too, by the way, Andrew? Oh, okay. Okay, cool. So we do have a statement on exactly why they scrubbed the first opportunity. They basically had a drop in stage 2 helium supply pressure, but they are moving into recycling operations. So what that means is these vehicles have helium that keeps the tanks at pressure. We've talked about a few times on the show now today that the tank pressure is an extremely important thing, because you have a lot of dynamic systems that are all at play here, and especially when the rocket starts to fly, you have liquids draining out of a tank, but obviously that could create a void. You have to backfill with gas, gaseous propellants or a gaseous inert gas. You have to backfill as the liquid drains out of it. You know, imagine if I took this bottle of water and if I turned it upside down and let it pour out, you know, there's going to be air needs to fill those gaps of where this is not sponsored by Smart Water, by the way. The air would fill the gaps of the water bottle, and you'll see that, you know, if you're pouring water out, it'll glug, 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 glug. That's air shooting back up the system. That obviously isn't going to be happening when something's being pumped, forced out of a tank. You have to backfill and provide gas back into those regions so the tank maintains pressure, so you don't have the tank getting like crushed or anything like that, you know, because that's actually what would happen if you drained it without backfilling it. So they backfill it with helium, and helium is good for a few reasons. Number one, it's inert, meaning it will not react with the fuel or the oxidizer. It will not cause any problems with combustion. And the number two reason is it's extremely lightweight and undense, and so it's easy to pack a lot of it into a small COPV, or a composite overwrapped pressure vessel, which is a high. They put these tanks under very high pressure, and that allows them to be able to stuff just an insane amount of helium in these little tanks, and then they can just vent a little bit of it out, and because it's so sparse, it expands it and can fill these voids. And that's why helium is used for that most often. There's also, sometimes they'll use nitrogen as also an inert gas, but it's not, you can't compress it as much and make it fill those voids as easily. So yeah, so that's actually a good thing. You do want a sparse gas when you're trying to fill a large volume. You might know, hydrogen tanks, for example, on say SLS or Delta IV Heavy, or previously the Space Shuttle. The hydrogen tank was huge because per mass, the volume it takes up is huge. So those tanks are just massive in order to have the same amount of mass in your tank. So lightweight molecules take up a lot of space, and that's a good thing for your backfill. So that's basically what happened. Yeah, so they had a stage 2 helium supply pressure, and they are that's what they're recycling and reworking. So yeah, that's good. Like we said, we're down to T-minus 31 minutes basically. So obviously the teams are moving to try it again. You do see, by the way, in this shot, you guys can actually see some white patches on the outside of the vehicle where liquid oxygen is stored. You can see just a little bit of white ice buildup. I'm not entirely sure, to be honest, why the whole vehicle isn't frosty white at all times. Maybe it's too warm out here, but you can see it there in that shot, which is pretty cool. So let's see. Let's see. This is again from Cadber, wanting to know a little bit more about the tap-off cycle. We have talked about it a handful of times. I definitely have to say, if you guys want to learn more about the tap-off cycle, I promise you, if you watch, I have a video titled "How to Power a Rocket Engine." It's all the different rockets, the cycle types of rocket engines. So things like pressure-fed, monoprop, bipropellant, hypergolic bipropellants. And you go into pump-fed, you go into electric pump-fed, and gas generators. You go into closed cycle. You go into fuel-rich and oxygen-rich closed cycle, or you go into full flow. But tap-off and expander cycle are two other types of cycle types. And what's unique about tap-off is that they literally basically take the high-pressure hot gas that's inside the combustion chamber, and they divert that gas into the turbine of the turbine is what powers the pumps. It's basically, I don't know if you're familiar with a turbocharger in a car. You basically flow the exhaust gas of each cylinder bank. It's pretty hot gas. It's high-velocity gas. You force that through a turbine that spins a turbine up, and then you dump that out, and then that is connected on a shaft to a compressor wheel. That compressor wheel then forces more air into the engine. This is similar, where it's taking a turbine, and you're basically taking some of the exhaust, some of the high-pressure hot gas that's inside the combustion chamber. You're shooting it through a tube at a turbine. That spins up the turbine up to high, like 30,000 RPM, and then that's connected to a shaft to a set of pumps. One set of pumps runs pressure for the RP1 for the fuel, and another set of pumps, or another pump then will put liquid oxygen into the engine. So that's what the tap-off cycle is. I go into a lot of depth in that video. I promise, if you haven't watched that one, that might be one of the most in-depth and one of the best walkthroughs of all of the different cycle types. And I love that video. I think that video, I have to kind of reference some of the things. I love learning new things whenever I make a video, a long-form video. And that's one of those where I still learned a few things, especially about enthalpy, which is the relation of heat and pressure and mass flow, and all these different things, and how they actually is used throughout the system of a rocket engine. Because you do lose pressure, you lose heat in certain areas as you transfer from say, heat energy into kinetic energy, or velocity into kinetic energy, pressure into kinetic energy, all the kinetic energy. There's a lot of that in rocket engines, and I go through that in great detail in that video. So I promise it sounds scary, but it's actually really fun. So this is a good question from Donovan Stagg. Wanted to know any specific reason they are doing a retrograde launch, and what are the advantages? The advantages, actually, there aren't advantages. This is hard. This is actually harder for them technically as far as a capability of the rocket. They lose performance flying retrograde. But the biggest reason, this is a developmental vehicle. This is a demonstration of a brand new rocket that has yet to demonstrate being able to get to orbit. This is the second launch attempt ever of this rocket with this company. And flying retrograde from California allows them to fly basically as far away from populated areas as possible. So although they're basically fighting the rotation of the Earth to get into orbit, this thing's fighting, having to run upstairs, like running up an escalator that's going down. That's almost like what they're doing. It's harder to do that, but that way, that's what the company feels comfortable with for their first orbital launch attempts. That's what the range and the FAA and all the people involved in issuing a launch license, that's what everyone feels comfortable with, and that's a great way to demonstrate your ability to get into orbit. It's just simply fly as far away from any populated areas or any things of intrinsic value. So that's exactly what the teams are doing. They're playing it nice and safe, and it'll provide a really good view for us here because we'll be able to watch it come up right over, from my point of view, like right over this mountain here, and then it'll look like it'll go a little bit to my left. It'll fly a little bit south, but a lot of west, and it's going to be really cool. So this is one of our views here, looking at the mountaintop there. Man, it is very windy. We got to apologize for the wind, even though it's crazy. Even though we're on some really heavy-duty lens mounts and things, no matter how sturdy it is, the wind has a different thing to say. So, yep, whoopsie-doodle. Let's see. So this is a great question from Yoman. Does that mean there is no pre-burner? That's exactly right. That's exactly the beauty of the tap-off cycle, is there is no pre-burner. There is no gas generator. They literally, it's crazy. They literally just take the already high pressure from the main combustion chamber and they just pipe it over. Now the hard thing and the thing that they have to solve, some of the biggest technology that had to be developed was how do you make it so the exhaust, what you put through the turbine is an okay temperature to not just absolutely destroy the turbine. Because the turbine can only handle I think Tom Marcusic gave it to me in Fahrenheit. And I can't recall those numbers off the top of my head in Celsius, but it's something like, the main combustion chamber I think was like 4,000 or 5,000 degrees Fahrenheit, and the turbine can only handle like 1,200 degrees Fahrenheit or something around that scale. Again, I'm just talking off the top of my head. So you have to find a way to make sure that the exhaust gas that's coming out of the main combustion chamber, by the time it hits the turbine blades and the turbine wheel, it can't be that hot. It has to be cooler temperatures in order to do that. And so that's actually part of the intellectual property. That's part of the beauty. That's part of the technology that Firefly has developed in-house. And along with, originally it was with Ukrainian friends that developed some of the pump systems. Yeah. There's about 200 engineers that worked on that system to be able to make the pump fed system in this that is using the tap-off cycle. Really cool cycle type. Again, it's never made it. No one's ever built a tap-off fed rocket engine, booster engine that's flown to orbit. So this very well could be the first rocket to make it to orbit with the tap-off cycle. I expect it to be. And again, it's a really cool technology, and I would love to know. I'll have to do some digging to see what options there are, because one of the ways you can cool off that exhaust is sometimes you have to dump more fuel to make it more fuel rich in just that flow of gas that goes through the turbine and through the turbine wheel. But Tom Marcusic said they don't do that. So that goes that makes me just go, how can you lower the temperature without changing your fuel to oxidizer ratio? So they've obviously developed something pretty cool by being able to come right off the manifold right there and send it right off the injector face, send it right into, it's pretty magic. I would love to learn more. So let's see. This is actually a good
Yeah,
question here
so
from.
what he said was like, guys, as I said, this is different from gas generator because there is no pre-burner. So in pre-burner, what happens? A small amount of fuel, mostly it's fuel rate, so more amount of fuel and small amount of oxidizer is used to have some sort of pre-burn, and then those exhaust gases are used to rotate the turbines, right? But that is not the case with the tap-off cycle. Tap-off cycle, all the gases which are in the combustion chamber are fed directly to the turbines. And the gases in the combustion chamber are literally at combusting temperatures, and proper fuel and oxygen mix ratio is there. So it is at the highest temperature possible. So how do you then cool it? Because you need to have a certain cooling temperature at that point of time when it reaches the turbine, and that's where their cooling system comes into place. Obviously they can't play around with the ratios because the gases are coming in from the combustion chamber. So they what I'm supposing is that they might be running in some those gases through the feed lines which are being cooled by the cryogenic engine cryogenic fuels. So those few feed lines must be cooled by the cryogenic fuels, and then these gases are must be like going through that, and then maybe rotating the turbine. I'm not so sure, but this is one of those solutions which can be used. So not so sure, but obviously it can happen. It can do like that. So right now T minus 21 minutes, 22 minutes from the liftoff. Everything is looking good, and yep. Let's hope we get to see the launch in this attempt now.
SpaceX Vandy, or in general, what we could actually just say, why is Vandenberg so underutilized compared to Florida and Kennedy Space Center, Cape Canaveral? Well, the simple answer is there's actually a limitation to where you can fly a rocket on the West Coast. Because don't forget, when you launch a rocket, you have to basically fly over unpopulated areas. All rockets look at least in the United States, whenever they launch a rocket, they fly it over unpopulated areas. So they'll fly over the ocean. They'll close off, the marine traffic, the flight traffic. They make sure that the rocket is safe from anyone nearby. And so in the U.S. you fly over the ocean. So if you're on the East Coast, you can fly eastwardly. You can fly in a low inclination orbit, meaning you can fly anywhere from about 51, 52, maybe 55 degrees. But at some point from Florida, you start actually running. If you go too far north, you start running into New York City and all those places. So you do have to fly at an inclination, an inclination. Again, if you're flying due east, 0 degrees. If you're on the equator, you would be going right around the equator. So that would be like a 0 degree inclination. 90 degree inclination would be going up and down over the poles. That'd be a 90 degree inclination. 180 degree inclination would be flying backwards, going backwards around the equator. So 51.6 degree, that's what the International Space Station is on. And that's close to the upper limit of how inclined you can fly from Kennedy Space Center without a dogleg maneuver. I have to say that because SpaceX has actually flown some really high inclination orbits from Kennedy Space Center, but they're doing that with these really big dogleg maneuvers, and because of that, they actually lose performance in the rocket. They can't put as heavy payloads into orbit. So fun little fact there. But Vandenberg has its own limitations. It can't fly eastwardly, so you can only fly basically in the polar corridors. You can basically fly polar orbits only, and or retrograde. So yeah, if you're launching something into space, you really are limited here at Vandenberg Space Force Base to what orbits you can get into. And it's just not really it depends. It's not really as common to fly sun synchronous orbits or polar orbits. They're good for Earth observation and things like that. And some communication satellites are helpful.
Not sparks. Actually, the cryogenic fuel is going through the engines. That's why those, those vents are coming out of it. Those white gas is coming out of it. So since that is cryogenic fuel, so it might be some when it is flowing, then it is interacting with Vandenberg humidity to make it frozen. And the things which are looking like sparks, they're not spark but just ice crystals falling out of the rocket. Uh, yeah, there is no sparks required here because it's not a hydrogen powered rocket. This is just RP1 and LOX, just like a SpaceX one. So it uses T-tab and does not have any explosion hazard, because it is not leaking hydrogen. So that's why raw fees are not required. Those sparks are not required, which is there in Space Shuttle or there in Saturn V, and it was not here in. It will be there in SLS also, the Delta IV Heavy 2, but not here in Firefly Alpha or SpaceX rocket Falcon 9.
Watch progress at Starbase. You know Lab Padre, 100%. So Lab Padre also has cameras in Florida as well, so they're no stranger to live streams. So thank you so much, Lab Padre and Lewis and the whole team there. Thank you guys for watching and tuning in. That really, really means a lot. So let's see here. Let's see. This is from Goat Pilot. Wants to know, are they using some sort of ram air to cool at higher Mach? Can we get scramjet rocket engines, please? 7,500 mile an hour cowl hood. So, no, unfortunately, for the most part, you have to realize going fast in an atmosphere is very hard to use that to cool anything. As you speed up in the atmosphere, even if it's in the upper atmosphere, as you start to compress molecules, compress air, it heats up. That's thanks to the laws of thermodynamics. So for using that to cool something off, it's actually really hard to cool something when you're going at high Mach numbers and things like that. So realistically, I don't know if you can use a cowl on high-speed, hyper-speed vehicles to be able to fly and to cool things. And frankly, the problem is, too, once it gets into a certain altitude and things like that, the rocket, you can't use air to convect and get heat away from it. You can radiate heat when there's no atmosphere, but to use convection to cool things, like a lot of us are used to fans cooling things here at sea level or on Earth in our atmosphere. We can use fans to cool things because you can blow air across it. You'll transfer heat from the object through the air. That's convection. But in space, and frankly, a much better way to do things is using liquid cooling. Because if you think about it, the rocket is actually, it has liquid propellant, really cold liquid propellant, or even the normal RP1 flowing through the engine. Think about, I don't know if any of you have like...
Hi home cinema mania, welcome to the stream. It's a pleasure to be here on your channel. Thank you so much, really appreciate it, man. Welcome, and let's enjoy this stream, and hopefully this thing launches today at T-minus 16 minutes from the launch.
So that's basically what they're doing with the rocket engine. They're going to be flowing a lot of propellant from these propellant tanks into the engine anyway. So what they do is they flow that propellant through the walls of the engine first as it's going from the pumps, and then they literally have these little channels through the nozzle and through the walls of the engine, and then that goes into the combustion chamber after that. It goes back up the wall, so kind of sometimes they do like a turnaround. They go down the nozzle, back up the nozzle. They'll cool the whole nozzle, the throat, up the walls of the chamber, and then they'll end up in the injector plate and flow into the engine from there through like a manifold and through an injector plate. So that's actually how you, and again, I have a whole video about how you cool rocket engines, because this is another one of my favorite topics, is how do you keep these things that are holding, temperatures as hot as the sun inside of these walls that would melt under those conditions? But there's a lot of really cool science and engineering that goes into making that possible without making it get destroyed and melty. So yeah, liquid cooling is definitely the preferred method. But a cowl is a fun idea, but I don't think it'd be a good way to cool things. So this is a good question from Owen Medford. What is the liquid dripping from the engines, fuel or liquefying frost? So actually, I can't speak to what it is at all times, but I think lots of times when you are just seeing it literally like occasional drips, that might be just condensation coming out of the condensation developing because the engines are very cold. They have been chilled down, and condensation will develop and drip off of the engine there too. And don't forget, there's also like frost on the outside of the rocket, so some of it might be making it down the fuselage and dripping. But you will see engine bleed in at some point when they, I think it was around T-minus 3 minutes, they do flow and get the vehicle ready for cryogenic temperatures. Because again, liquid oxygen is extremely cold. When it hits that pump, the liquid oxygen pump, if you don't prepare that pump for all of a sudden an onslaught of really cold cryogenic propellant, you might crack or break or ruin the pump. So they have to first start flowing propellant through the engine to get it thermally conditioned for the cold temperatures. Isn't that weird? When we think about rockets, we think about the hot temperatures. We think about the crazy flames and exhaust shooting out of the flamey end of the rocket. But really, it's the cold that they have to thermally condition the rocket engine for. I think that's super cool. All right, so we do have an update that they will be moving the T0 time to, did I hear correctly? Can you repeat? Okay, they are moving their T0 time to 7 p.m. That is the absolute back end of their window now. Which,
whoa!
If that thing flies at 7 p.m., that's going to put on quite the show because sunsets at 7:15. So, if they do go right at that 7 p.m. window, it will be a beautiful, beautiful launch. So that is 3 hours from now, which means I'm going to be taking a few breaks here, so I'm not just yabbing on and on and on and on for hours and hours and hours. But we will get that updated. There we go. We already got it updated. T-minus 2 hours and 51 minutes is our official new T0 time right at the end of their 4-hour launch window. Again, their window opened up at 3 p.m. Pacific time, which I think is +7, so 15, 22 UTC. So now we're moving into a new T0 time at the end of the launch window, their 4-hour launch window, right at 7 p.m. So, yeah. So hopefully we hear, hopefully the teams are not working any big issues and they are able to get this off the ground today. But we will stand by for more information as soon as we know it. But yeah, thank you guys for tuning in. This is still just the absolute dream for me, just to be here. The fact that I can actually update, I love it because so many times when I'm doing launch commentary or something, there's a lot of speculation and we don't have the answers and we don't know. We're just like, well, maybe the teams are doing X, Y, and Z, and we really have no idea. But it's fun for me to actually tell you, like, yeah, they're working on the helium pressure was the first scrub, and now maybe they're working. Whatever, maybe they're looking for weather. We don't actually have the updates. I'm bragging about having information, and I currently don't have information to brag about. But the fact that we actually know the T0 time is now 7 p.m., so it's at the very end of their 4-hour launch window. So let's go ahead and I'll answer a few more questions just to, answer questions. Actually, you know what, Andrew? At some point, let's queue up. There is that video that they have about the second launch attempt. Maybe we'll queue that up. Let me know when that's ready to go to air, and I'll answer one more question. I don't remember. I think it was originally called.
Okay.
I don't remember what title of that video is.
It's a very long time for me to stay awake. It's already 5 a.m. here, and at 7 Pacific PST, it would mean around 7:30 here. So I don't think so. I can be wake up. I can't. I can stay awake for too long because I have an office tomorrow.
That's the whole point.
So maybe let's see. We'll see. But right now we are at a hold 7 p.m. PST. So let me just maybe update it. Let's see.
Actually has a vehicle that's going to be scouting 4 Artemis landing sites.
But yes, I might go away for some time and then come back again. I have an alarm or something like that, so that I can witness the launch. But for sure, I can't stay awake till 7:30 because I have an office. I would miss that for sure.
NASA, all these cool opportunities that are cropping up. I just love seeing that. I love seeing a company like this make a lunar lander that's going to help us know if a certain location is safe to land on the moon. That's really cool. But more on that in a second. Let's watch that video here from that talks about the first launch attempt and the second launch attempt.
Commit for launch.
Achieving first flight is a huge milestone for a rocket company.
3, 2, 1.
But ultimately, this business is about getting to orbit and doing it repeatedly. We did learn a lot from the first flight. We fixed the minor problems and are ready to get back to the launch pad. What has impressed me most is the growth of the team. When we tested the first flight vehicle, it took us over 18 times to get it fully functional. In getting ready for this second flight, both the vehicle and the team performed flawlessly on the first attempt. We've gotten smarter, faster, and more disciplined.
Made it all the way.
We are ready for orbit. See you at the launch pad.
And there we are at the launch pad. I think that's really cool. Again, we've talked a little bit on air about what some of the exact changes are to the vehicle, and really, frankly, they didn't do like changes. Actually, they did increase the thrust 8% though from the first rocket to the second rocket. This vehicle actually has 8% more thrust out of its Reaver engines, and that is mostly thanks to just at first you're running these engines really carefully. You're running them very conservatively. You do most of that with your oxidizer to fuel ratio, so your OF ratio. You hear that, and the closer so. They basically were running at like a 2.2 OF ratio at first, which is very conservative. Now they're up to a 2.3, which is a little bit leaner. It's a little bit hotter. It's higher performance though, and that's so that's how they were able to get that. They're aiming for closer to like a 2.4 at some point, and they can increase the capacity even more then. So I think they're aiming for, again, I was quoted in thrust in pounds. I don't remember if they show thrust in pounds on their website or what. They do, but yeah, they're aiming for like 45,000 pounds out of each engine, and I think they're currently now at 42,000. So they've already gone up quite a bit from their first vehicle. So good to see them continually working on things and making upgrades already. But for the most part, the vehicle itself is the same. They're just kind of tweaking and tuning the engine and tweaking and tuning some of their systems on hand just to make it, more robust, more higher performance, and more production ready. I think that's kind of the big things that the teams are working through here. So let's see. This is a good question. This is a fun one to answer here. Wondering Fool, thank you for your tip. Asking, how many cameras does the team currently have set up? Also, this is a wonderful time to be a space fan thanks to the new vehicles and technologies. 100. This is like the ultimate time to be a spaceflight. It's got to the point now where there's so many exciting things, it's easy to miss things in the spaceflight world. And I think 5 years ago, 10 years ago, there were so few things going on in the spaceflight world that any launch was like, oh, there's a launch. There's like 6 launches a year or something. Like, just very, it is so easy to tune into every little thing. And nowadays, there's so much exciting stuff. There's so many new big updates, so many new things to get excited about that it's actually easy to miss some of the things. But I wanted to answer this question. How many cameras does the team currently have set up? We could do a little camera tour while we're hanging out here. This is one of our cameras on... This is kind of behind some of the fuel, or in front of some of the fuel tanks. There's a wall similar to the one you see kind of in the bottom right. This is the engine cam. This is a Firefly provided camera. It's an engineering camera looking at their engines. We also have beloved trench cam. This is the flame trench. This is where when the rocket lights up, there is a flame diverter, so the exhaust will shoot out the side through this flame trench, which will, if you pull up the next shot, will also show the flame trench. But okay, we'll see that in the next shot here. We also have the teams at mission control. So we do have cameras inside mission control here. Then we have some tracking assets from the range. These are really high-end tracking cameras that track the vehicle on its way to orbit. This is another Firefly-provided camera. Is this also a tracking camera? This is another tracking camera. So we have 2 range-provided tracking assets, which are going to be awesome to be able to follow along. This is one of our cameras. That's the one looking at the strong back and looking at the umbilicals. And of course, once the rocket takes off, you will see the engines go right through that shot. We might not cut to it live on air, but we are recording, so we'll be able to have that beautiful ship footage. This is the shot, the other shot of the flame trench. So you can kind of see the yellow bits there of the railing. Down in there is that pit, and that's the flame trench. That's where when the rocket lights, the exhaust gets diverted out there, and it will make a whole bunch of smoke and exhaust a big plume right there. That'll be a fun shot to see at liftoff. And then this is back to our first camera. So those are our cameras on the pad. We personally have 4 4K cameras. Oh, here's another 4K camera at the pad too. So we have 4 of our own 4K cameras to provide you with the beautiful views that we see here today. But then also here with us, we have a couple of tracking cameras as well on some pretty large tracking mounts. And I don't know if we'll punch those up or not, but we do have some really long lenses. This is one of them looking right at the mountain. That the rocket's going to come up right over that mountain. That's another one looking at the water tower. We use that as a reference here to know where the rocket's going to be. But that, yeah, you're actually looking through a lot of glass there. When this rocket comes up over the mountain, even though it's relatively small, we'll have a really tight shot on it. It's going to look awesome. So, yeah. All right, let's keep going here with messages. Okay. What? thank you so much to Sarah Hankins. I'm speechless. Thank you so much. Everyone say thank you to Sarah Hankins for the most generous super chat you can even do. Holy crap. Thank you, Sarah. Thank you. From the absolute bottom of my heart. That makes this stuff all possible. There's just been countless days of getting the team out here and flying everyone in and setting up and the food and the gas and all of the things. Thank you. That really means a lot. That's what makes this stuff happen. So I really, 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 really appreciate that. Everyone say thank you to Sarah. That is just, yeah, you make this happen. So thank you so much. And yeah, I don't even know what to say after something like that. How can people be so generous? That's huge. That makes this job feasible. So thank you so much. And also, I feel like I do also owe our patrons and our YouTube members a huge shout out too, because again, especially lately, as you guys know, those of you that have watched my videos lately, I posted a video a couple weeks ago about the build out of our 4K production truck that we're using today, that we drove from Florida to California. We've been working on that for months and months and months now. And we could only be doing that because we do have some incredibly generous support from YouTube members and Patreon supporters that make that stuff possible. So I love to make videos. Videos are my passion. I love to do these deep dives. But lately, we have some exciting things happening in the spaceflight industry. We are here at the first, hopefully the first successful launch of a brand new rocket company with a really impressive rocket using the tap-off cycle, doing all sorts of brand new things. This is the very beginning of a company, a really exciting company. We're able to provide coverage for that because we were able to do this awesome van. We also are able to cover Artemis program, the initial launches of SLS and the Orion capsule to the moon. I mean, come on. These are huge milestones. We have SpaceX working on Starship. This is the start of a really new era in spaceflight with commercial companies making really exciting vehicles. This is the time for us to really be diving in and capturing history. And this is, you guys make that possible. I wouldn't be able to do this at this capacity and be able to do this without your help, without your viewers out there, without the support and being able to do this thanks to the teams at Firefly with this particular mission. This is just an absolute dream come true. So again, thank you. Huge. So thank you so much. Man, I don't even know how to move on from there. I feel like we almost need to just take a break because that's like a mic drop from Sarah. Thank you so much. Man, wow. Okay, I feel like I'm speechless. So thank you to all of you that support. If you, again, remember, if you do have a question, you don't have to do a super chat or donation to be on air. Our moderators are looking for good questions to put into our queue, and I'll gladly answer any questions. I feel like we've answered a lot of fun questions about the tap-off cycle, about carbon composites, about flying retrograde. But I feel like I can't think of any offhand, but you guys always come up with such good questions. Let me know if you have one, and I'll be happy to answer it to the best of my abilities. Again, I've been absolutely fortunate enough to be working with Firefly on this. We get updates from them. Obviously, we have a very close working relationship to be able to provide you the stream. And although I am kind of their voice today, I am not officially with Firefly. So I might make a boo-boo, and that's not on them. That's on me. So just keep that in mind, too, that the things that I say here on air, I'm like a free agent. They're somehow trusting me to speak for hours and hours. But that means the world to me. That means that is just the ultimate dream come true for me to be able to sit here and just nerd out over rockets for hours and wait for what's going to be a gorgeous launch here out of Vandenberg Space Force Base. So, again, thank you to the teams of Firefly. So here's one of those things that just is so fun to see. Funky Cold Medina says, change career from a bachelor's in education in 2015, Earth and space science teacher now, hoping to go to space someday. Until then, thanks for bringing it to me. That is so cool. I feel like I would have loved to have a teacher excited about spaceflight when I was a kid and when I was in high school and things like that. But I didn't. I didn't have anyone mentoring me to get me excited about spaceflight because, frankly, I don't know if there was anything really that exciting. The space shuttle was so routine when I was growing up that flew and people just weren't really paying attention. But we are definitely in a new era where there's a lot of new ground being broken, a lot of new exciting things happening. And it's thanks to wonderful educators out there, helping get kids excited. I've seen so many people post pictures of, videos or using some videos and live streams. Like I've seen my videos be used in the classroom, which is the ultimate like compliment. I've seen teachers post pictures of NASA spaceflight or Lab Padre or some of the other content creators out there making videos about spaceflight, using that in their classroom to get kids and people excited. That just means that's so cool. That's what it's all about right there. Is I feel like you only really just like anything, if you learn more about it, the more you learn about something, the easier it is to be excited about it. I think for me, I'm not really a big sports fan. We last night while we were setting up and eating, we played a game of Tim tried to name the professional team from like a city. I couldn't name hardly one from like any city. Although Ryan, from Cosmic Perspective, you might have me beat with not having good sports knowledge. But I think it's because neither of us have the knowledge. Therefore, it's hard to be excited about sports. But people that know like every player on the team, they know the history of their favorite team. Of course, they're extremely passionate, and it's the same thing for spaceflight. Like I think the more you know and understand rockets, understand the history, understand the progress and where we're going, how can you not be excited? That's the whole thing for me. Is this is becoming kind of a spectator sport. So, yeah. Let's see. So, let's answer a few more questions here. Rockets red wines. I'm 20 miles east of Vandenberg, and storms are brewing up. Hope the weather holds. Stay shiny. Yeah. If we look over to our east, we are. Could we actually get just one of those cameras pointed east? We are. It's overcast over this way, but it is. It's pretty clear blue west. So I'm able to look and see. Oh, we're dialed in. So maybe we don't want to move. Oh, we can talk about the, yes. So we'll do that in a second. Ryan's reminding me that we actually have, so you can see from this camera here, we have a lot of overcast skies here compared to the pad that looks clear. A lot of our cameras there look bright blue. But yeah, we got some weather it's just kind of getting grayer and grayer the further you move east. Let's see this shot. I'm trying to think about which direction this guy's facing. This is more or less facing east, actually. So this is seeing that storm cloud kind of move in, actually. That's a good view there, Andrew. I like that one. 'Cause that's giving you a sense of some of the weather they might be contending with. So that might actually be why, one of the reasons why the clock has moved, why the T0 clock has moved. So, yeah, good to keep as a reminder. So thank you so much. Let's keep answering some of your questions here from Alex Jones. Thank you so much for saying Ad Astra. That camera's looking west. Double check that on Google Maps for me. I'm pretty sure that one's east, but because the ocean's at its back, so it's looking east. Yeah. So let's see here. Matthew wants to know, will I be live streaming or watching the ABL Space RS1 launch? Yeah, I don't know exactly when I haven't really heard any updates yet, but absolutely. I mean, there's so many rocket companies working on their first orbital launch attempts, and so far the number of private space companies that have made it to orbit is very small. So the race is still on to be on that list and be the first ones out the gate to be able to make sustainable and continue access to space available. And that's, of course, what Firefly is aiming for. And they've got the facilities, they've got the, hopefully, they're proving out their vehicle here with this. That's exactly what today's demonstration mission is for. Prove they can make it to orbit with this vehicle and then start cranking them out. That's the name of the game, and the race is on. So far in history, as far as privately funded, not just government rockets, it gets tricky because governments hire private companies to make rockets in the past, but privately funded rockets that are clean sheet designs to get to orbit. So far, we really only have, SpaceX was kind of the first one to do it. Again, arguably, there's asterisks all over all this. And then Rocket Lab made it to orbit in, 2017 or 18? Since then, we've seen Virgin Orbit make it to orbit. We've seen Astra make it to orbit. And that's pretty much the end of the short list as far as clean slate liquid-fueled rockets. There's been some out of China, but most of those are based off of missile systems and solid rocket boosters. I don't know if they've had a single clean slate design private company make it to orbit yet. So the list is very short. Very short. That shows how hard it is. And the list of people trying to get to orbit is over 100 right now. So the race is on, and of course Firefly is positioned very well here with their second launch attempt. Their first one being very successful and learning some very valuable lessons on a developmental vehicle and on a demonstration flight. I feel very good about this vehicle. One of the fun things that I learned too, the first vehicle when they developed it, because it was their test bed. It was their very first vehicle they had put together. They had cycled it like 18 times to be able to get it to be able to really do a static fire and be able to do some of the testing. This rocket has been able to hit milestones on on the first attempts of everything. So as far as just having like a rocket that's been kind of used and had many cycles going, because they had to use it as their test bed, that rocket had a lot more experience, and sometimes that's not always a good thing. This is a very fresh rocket that's behaving incredibly well. So the teams, everyone I talked to was just like, yeah, this thing's absolutely ready to go. They just feel very confident about it, and it's just, they're like, yeah, this thing is great. So that's really good to hear. So this is one that I still need to learn a little bit more about, but I'll take the question anyway, Bruce Ackerman, because yeah, it's actually, a lot of it goes back to some of the traditional aerospace companies having an L- time being the time of launch, but T- time is the terminal count. So like what the countdown clock tells you, and the actual time when it's going to launch don't always line up. So for a lot of the heritage companies, such as United Launch Alliance, or with SLS, they're using the heritage companies such as Boeing, Northrop, and United Launch Alliance, Lockheed Martin are in that vehicle. And the way they used to do things, especially back in the day, was they would kind of have like a prop load procedure. They would load the rocket up, and then they would pause and hold and do a systems check, and then they would go into the final countdown. And so there was a time where they're counting down in their clock, but then they'd hold it and they'd evaluate, and they'd go over all their systems, be like, how is everything looking? Okay, now we resume or start the new actual like automated launch sequence from there. And so they would have an L-, launch minus X amount of time. And they'd also have a T clock. And it's really confusing. I don't like it. I don't think the public needs to ever know anything about the internal clock. Just tell us when the thing's going to launch. And that's what we have for you guys. We have the T- is the time. I think technically it is actually an L-, like launch minus this time. But that is the difference, the technical differences. As far as I understand, I might be a little bit wrong in some of the technicalities and the reasons, but basically, L- is what we probably all should have been using this whole time, and that should be the only thing we ever heard is like, when is this going to launch? Minus X amount of time. So, yeah. Let's keep going here. Flawed Perspective, thank you for becoming a member. Really, really appreciate that. Let's see. This is from Kai saying, hey, Tim, nice with the rocket launch. Chase Van, new idea, everyday astronaut, private mission control. Everybody start supporting Tim. Thank you so much, Kai. I really appreciate that. Yeah, my goal here, I don't intend to be out there covering every rocket and doing it, going coast to coast, chasing rockets. I would never produce a single video again, and that is absolutely not what I want to do. I want to be producing videos, but it was a race to try to get this vehicle online and ready to go for this mission, for Artemis, for future Starship missions, for some of the big ones that are right around the corner here. It was a race to get this thing online and ready to go. But realistically, I love watching a rocket launch, and the only reason I really stream is just so I can help share it with you guys. I just love seeing these things in person. I love feeling the rocket launch. I love hearing it. There's nothing like it. I mean, there just really isn't anything like it. Watching something go into space. I mean, come on. How crazy is that? I'm fortunate enough to be able to be at these launch locations, at these launch pads, seeing this stuff happen in real life, with my own eyes, and I want to just do the best job I can to bring that to you guys. So I don't intend to be out there being a rocket broadcaster every day, but it is nice to have the option of driving the van to a launch pad and providing you guys coverage as best I can. That's the ultimate goal. So, yeah. Oh, again, big thank you to Sarah Hankins for becoming a member. Really, really appreciate that. And Lab Padre became a member. That is awesome. Really appreciate that support. You guys are amazing. Again, you guys all make this happen. There's a few other members like Curtis and Renee Bingle and Bradford Ben. Thank you guys so much for the memberships. We try to do some live streams whenever I have time to do just kind of some more one-on-one, more intimate streams just to answer questions and hang out. They're a lot more casual. So if you guys like that, like to just kind of nerd out and talk rocket science, and like literally it'll just be me in a room Googling stuff with you guys and learning together. There's some of my favorite things to do. So if you guys do want access to things like that and other behind-the-scenes content, YouTube memberships and Patreon, you guys make it happen. So thank you so much. Let's see. This is from Montrose family, what orbits potentially does Firefly specialize in? Very good question. So when they're right now, their current active launch pad is out here at Slick 2 at Vandenberg Space Force Base in California. So they are limited to being able to do polar orbits, or polar / like retrograde orbits from here, as we're going to see today, a retrograde orbit. But yeah, I think the right now they can't do, like, say, a normal low Earth orbit, low inclination orbit, or they wouldn't be able to fly to the International Space Station from here. But this is a very high performing vehicle, and a fun thing you can do when you have performance to spare is you could actually fly to, say, the moon, or, I mean, if you had a really light payload, you could fly to, Venus or interplanetary missions. You can actually do that from a polar orbit. We saw that happen with, it was InSight. The InSight lander launched on the smallest Atlas V, and it launched to Mars from a polar orbit from Vandenberg Space Force Base. So it did not even get to account, didn't even get the extra rotation of the Earth to help boost it into orbit. So it's totally capable to fly on missions to the moon and interplanetary missions from a polar orbit, but it just takes more energy. So you're much more limited on your payload. So say if you could maybe say, I'll make up numbers. Say you could originally launch 100 kilograms into orbit. If you're trying to launch, and say maybe if you're on the East Coast or something like that, you might get, I don't know, 20 kilograms to the moon. But if you're trying to do it from a polar orbit, it might literally be like 3 kilograms. Again, I don't know the numbers, but I'm just helping you understand that there are huge performance hits on when you're launching from different orbits. So they are limited on those orbits. But for now, again, they're just demonstrating the ability to get into orbit first from Vandenberg, and the options from there are just limitless. They could expand out and have more and more launch pads from here. But for now, they're just keeping it simple, keeping it safe, and demonstrating the ability of their Firefly Alpha rocket. So, yeah. Oh, man, this is a great question from, I believe this is Ryan at D-Pod Dolphin. Will I be able to head to the UK and stream the first launches from the UK? I really, really wish I could. I don't know if I'll be streaming, but I would. I've been over. I've been to Europe a bunch. Like, I've been to Ireland. I've been to Netherlands and all that stuff. But I've never been to England and up there. North. All those places where the new launch pads are. I have not made it over there yet. A rocket launch would be a pretty good excuse to go to the UK. So maybe someday. Maybe someday. Let's see here. Oh, man, this is from Dub Selector. You were excited, but we were not when we had to pack up and leave the launch site. Can't stay long. You're bummed. I understand, Dub. Dub Selector. I totally get it. Trust me. Unfortunately, rocket scrubbing is just part of the game. Trust me. I've been watching spaceflight now so many rockets launching in the last 8 years, and it is very, very, very normal to scrub. That's just part of the game. It's the hurry up and wait syndrome. It's so funny. I understand that some of the frustrations as the casual observer. So you have to imagine your disappointment watching those of us at home, those that have come out to Vandenberg to watch. How disappointed you are when you get a scrub. Imagine how the teams feel. The pressure on the teams, the pressure, the disappointment when you get the scrub and recycle. But there's still an opportunity today. We are still T-minus 2 hours and 24 minutes. I mean, they are still aiming for the end of their launch window here, 7 p.m. Local time, that's Pacific time. They are still going for it, but I understand the frustration and the constraints of, if you have kids and a family, you drove here 6 hours or something to see something. I get it. Trust me, we drove the van, a stinky old news van across the country to see Artemis and set up for hours and hours and hours for days. A lot of our team members literally did not sleep. I was fortunate enough to get a couple hours of sleep some of those nights. But our team members literally didn't sleep, setting up all night, only to have it scrubbed twice. So the scrub, I fully appreciate and feel the heartache when the team needs to make a decision to try again and recycle and scrub. But they're still looking like, they're going for an opportunity at the end of the launch window still today. We will see how that goes. So Kyle Murphy, video game controllers throws a face to, oh, this is, sorry, this is one of those emojis basically put into text form. I was like, what? I'm reading this video game. Yeah. Thank you, Kyle Murphy, for that. I really appreciate that. Let's see here. We have, oh, thank you so much for Chazzy Mac. I'm very familiar with Chazzy Mac's name. Been a subscriber for over 2 years. Love the content. Thank you, Chazzy, for saying that. Really appreciate that. It's been just an absolute pleasure to teach what I learn about spaceflight from experts. It's so fun for me to be able to go and talk to people that know. I get to talk to some really, really brilliant people, and I love being able to share that with you guys. It's a dream come true. So this is the dream job. So thank you for those of you that do tune in and hang out. Let's see. This is really cool from Rad Pug Guys. Starting my first internship in aerospace next month. Wouldn't have switched out of marine bio if it weren't for your videos. Thanks to you, and sorry to the fish or whatever. I'll no longer be helping. Hey, you know what though? In the aerospace industry, you can help fish maybe much better than you could potentially as a marine biologist, because some of the things we do with space assets is study the Earth in a vantage point and in a way that you just physically can't do at scale from Earth. I know that sounds weird, but literally some of the satellites and some of the ways that we observe the oceans, oceanic rise, temperatures, study patterns of different things and the temperatures and the currents in the ocean is only available thanks to science instruments in space. So by being part of the spaceflight community, by being an aerospace engineer, you literally don't know how many fish you might potentially save because of a rocket you built that a scientist thought of a cool experiment to study some habits of blah, 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 blah. Next thing you know, it's like, hey, we could actually do this, X, Y, and Z. Because that's the beauty of the human ingenuity is we're constantly pushing boundaries and learning more and more about our place here on Earth and amongst the stars. And it's just amazing what things happen on orbit and what things happen with observations of our own planet from space. So very, very, very cool. Let's see here. This is a good question from Chazzy Mac again, asking, have we had the pointy end up flaming end check yet? We did. We'll probably have to do another one when we get closer to T0. But speaking of, I got to take a little voice break. I'm sure you guys are hearing it. I'm not used to talking this much and talking this long. I haven't done these long-form live streams in a long time. And just while we wait for the teams to get closer to pressing the vehicle again for flight, and as we await further updates, I'm actually going to take a little bit of a break. So just stand by, and we'll wait a little bit more information. Give me a little bit of time. I'm just going to take a break, and I'll be back with more information hopefully soon. welcome back. I have some good news for you. The teams have reset the clock for T-minus, well, it's 58 minutes. When I heard the news, it was T-minus 1 hour. They are going for 5:50 Pacific time. I have a hard time saying Pacific, which is just after, I think that'd be like 50 UTC, if I did the math right, just quick at the top of my head. Probably wrong, but yeah, that's coming up in less than 1 hour. But you will notice in that shot, you see some dark clouds. But currently, despite those clouds and despite what looks like could be potential weather violation, we are actually still go. So the teams are go. Weather is go. Everything looks good. It seems like they have resolved the issue that was halting them from continuing on further into the count. We're go, my friends. And with that, yeah, let me know if you guys have any more questions. I'll wait if we have any more confirmation or update on what exactly the teams were working through, whether or not it's just range and weather violations or hardware or whatever. We will update you guys as soon as we have any new information. But for now, we're T-minus 55 minutes, and I hope that this thing happens today, because we still have some beautiful blue sky over here, and I want to see this thing go with blue sky in the background. As you can see from that shot, that's what some of the sky looks like, and some of the other sky looks really dark. So I hope that we can get this thing in here while there's some blue sky left, because it is just a gorgeous day. So, all right, let's answer a few more questions. I got to point out that we had another insanely generous donation from Curtis and Renee Bingle. Thank you, guys. That's insane. Thank you so much. I know that it just says undefined there on our screen, but I see there that it's a little donation graphic that popped up in chat. That means the absolute world to me, and that makes all this stuff possible. So thank you so much for helping us to be able to do stuff like this, to be able to cover these launches for you guys. So huge thank you. That really just that's insane. I don't even know what to say. Thank you so much. Yeah, I wish there was like a question I could answer for you guys, because I feel like you owe some time, but thank you so much. I actually found a good question here. Oh, so real quick, I want to say thank you to Curtis and Renee, because that is incredible. So thank you. Meanwhile, I've got a really good question. This will be a question answered, sponsored by Curtis and Renee Bingle, but also from Paul McCormick here. This is, what is the green flash at the beginning of the engines starting? So this is actually a fun one, because it's a video topic that I'm working on. I've been scripting while on the road, while Ryan drives, and when I have things I'm not working on, I've been going to script mode, which is something I'm excited about. And I'm talking about how do you start a rocket engine. And there's a lot of different techniques. There's a lot of things you can do, like in Russia, the way they light the Soyuz engines. They literally stick basically wooden matchsticks up inside the combustion chambers and start ignition process that way. Because if you just take your fuel and your oxidizer, if it's a normal RP1 and liquid oxygen, and you just let them hit each other, nothing happens. And as a matter of fact, you could potentially have something unintentionally explode. So you need to control the combustion. You need to start the combustion process in a controlled manner. And a common thing that people are using is TTEB. It's triethyl aluminum triethylborine. And what that is, it's a pyrophoric fluid. And pyrophoric is kind of like hypergolic. Maybe you've heard of hypergols. Hypergols are used in upper stages a lot. They're a fuel and an oxidizer that when they come in contact, they will spontaneously combust. They're very reactive to each other. They will combust just on contact with each other. But pyrophoric means it'll combust under contact with oxygen. So what they do, they'll begin to flow liquid oxygen, and they'll inject TTEB into the combustion chamber. They'll begin the combustion process with TTEB, basically, and oxygen, and then they'll start flowing the fuel into that. So the fuel is coming in to the engine with combustion already happening with it, with an ignition source already available there in the engine. And because I believe it's actually the alumina, the triethyl aluminum, triethylborine, I believe it's the aluminum that is actually green in that flame upon startup. So you'll see that actually this engine uses triethyl aluminum, TTEB, for its ignition source. And I don't remember off the top of my head if that TTEB source, I believe that's actually a ground-based system for the first stage. So they'll actually store that TTEB in a ground system, and they'll inject it into the engines, through the umbilicals or something, through the launch mount, and that starts the engine process. Or perhaps it's stored on board. But for the first stage, I think it's ground system. But then for the upper stage, they do have to have it in a separate container to be able to hold and store that TTEB for engine ignition of their Lightning engine, their upper stage engine. So yeah, that's what that green flash is. And sometimes on shutdown, you'll actually see that green flash too. And I'm not entirely sure. I don't have the answer to this, but hopefully someone does out there. If you do know the answer, let me know. I think you can also use it to just ensure that you have a smooth shutdown process. So you basically kind of like weed out your engine or your fuel, but you don't want to totally just cut something off. You could end up being really fuel rich or fuel rich or oxidizer rich or something. So I think they can use TTEB again as a transition to get out of your shutdown process. I think, because you definitely see it at the. I've stood next to a Reaver engine, as close as you can be to a Reaver engine firing, and at first you see the green flash. It fired for like 20 seconds. I was blown away, literally just like sitting there in the presence of this engine, very bright, and then it shut down. It also had green. So I don't know if that's TTEB or if that's just copper potentially at that point too. But yeah, really, really, really cool stuff. That's the kind of stuff that I get nerdy about, and I love it. So let's see. This is a good question from Tom Renroff. If the weather is threatening to be an issue, is there much in the way of weather protection at Vandenberg? So for, let's say, lightning, for example. That's actually an interesting question because that became a pretty big topic out at Kennedy Space Center with SLS on the launch pad. You see very clearly their lightning protection system surrounding the launch pad. There's 3 huge, massive lightning towers out there that are there to help protect the launch pad and the infrastructure and the rocket from lightning strikes. So it's grounded, and it just basically attracts lightning. So if there is to be lightning, instead of hitting the rocket, they go through these lightning protection system. And actually out here, I don't have a good answer on why there is, other than I think maybe lightning is just a very rare occurrence out here, potentially, because there are not those same lightning rods on the pad. I do assume there's some considerations for lightning strikes and things like that, but I don't think it's nearly as big of a deal as it is at Kennedy Space Center, which is actually one of the highest lightning capitals of the entire United States. It's way up there on the list of most lightning strikes. So they definitely have to be extremely cautious out there at KSC. But I don't have a good answer for sure. Yeah. Oh, so by the way, Philip in our Discord says it's the TEB, not the T, that makes it green. So it must be the borine maybe makes it green and not the aluminum. You're right, because aluminum, you don't see it burn green. You're absolutely right. You don't see aluminum burn green because you see aluminum get ejected out of solid rocket boosters, and that's not green. Those don't burn green. So you're absolutely right. It can't be the aluminum. It must be the borine that burns green, or the boron, or however you actually say it. But yeah, thank you for that update. I really appreciate it, Philip. You are helping me stay smart. That's what I love about this whole thing. Is we have communities out here. We're all learning together. I'm no expert. I just am a very curious individual that just loves to learn and then try to teach you guys what I've learned. That's basically my career. And it's so fun that there's a community of people out there, and it's so fun. I mean, I have just even being here on base, we're connected and dialed into a NASA infrastructure, and people come out and they'll, I get to talk to actual experts that literally work on spacecraft and hardware, and talking with the teams at Firefly here. I've literally been talking to engineers, and I get to learn and absorb as much information as I can. It's just an absolute pleasure. So, yeah, there you go. Boring is what burns green. So I'm learning. Hopefully you guys are learning too. Jeff Duncan, thank you so much. I really appreciate that. Let's see. This is a good question here from Ryan's Random Videos, asking, "Hey Tim, what would happen if the rocket engine had 2 failures, or if the booster had 2 rocket engines fail?" So obviously, at some point, you can't. If you again, from my interview with Tom Mercusic a year ago, he kind of said, like, at some point you have to chisel out and weed out the nice to have things. You can't design a rocket with 10 different variants of it. It'd be nice to have this, because at some point you end up with so much pork and so much weight, you don't even have a vehicle capable of making it to orbit, let alone carrying anything else to orbit with it. So you really have to trim the fat, and you really have to make these things lean. That's why they're using carbon composite structures. That's why they're using a high-performance tap-off cycle engine. It's because you can't just always be going, what if, and at some point you just got to make the system reliable. And so that's what they focus on. They focus on, I think near the certain regimes you might be able to have one of the 4 engines shut down, but I don't think there's really much consideration or the ability of 2 engines shut down. just because you might not be able to have the appropriate and the proper amount of thrust to be able to continue on the way to orbit, get the acceleration you need out of the first stage. Obviously, the upper stage is only a single engine, so you have to have, you definitely have to have that performing well and reliable in order to achieve orbit. So again, kind of some of those things are nice to have things, but I don't know the answer on if they could lose two or not. So let's see. This is from MB Hutek wants to know. So if this mission is To The Black, will that mean the next mission will be called Tell 'em I Ain't Coming Back? Because that would be completely awesome. I'm not sure what their next mission will be called, but I like it. That's a very, very good observation. Thank you for saying that. This is Kat, who I believe I'm familiar with in our Discord channel. The green is boron component, and the TEB part was also used to light the Pratt & Whitney J58 in the SR-71. Hello from Sacramento. I love learning. See, this is so cool. Thank you so much, Kat, for that. So yes, apparently they also used triethyl boron as part, was also used to light the Pratt & Whitney J58 and the SR-71, the infamous and amazing SR-71, one of the fastest plane or jet, I guess, ever to fly with that beautiful engine. There was a lot of cool things, like to start up those engines. I'm pretty sure they had to use an external combustion engine, like a huge, very powerful. I don't remember if it was like a supercharged V8 or something. It was a pretty powerful engine just to spin up those engines, to get the turbines spinning and everything up to operating pressures. That's a whole nother. There's not a built-in motor, if I recall. But yeah, so. Okay, so let me answer this one more question, then we do have one more update. Let's see, in talking with Firefly, have you heard when they plan on building up Slick 20 at Cape Canaveral Space Force Station? They had a groundbreaking ceremony in 2019 for the pad and factory outside of KSC, but nothing since. No, I don't know what their current status is there. I think, again, the teams are being conservative and smart about making sure they can get to orbit before they totally continue on and build everything else out. But it is, I forgot actually that they had Slick 20 as an option. So I know that is absolutely in their plans to have multiple launch locations, and that's definitely one of them in the books. But as far as current building plans and things like that, I don't have any information myself. Maybe that's something I can get an update on here at some point. But remind me again, Andrew, if you want to repeat one more time, confirm. We do have an update. It is not a good one. The teams are scrubbing today, unfortunately. They are actually, what you're seeing there, you're seeing them detank as we speak. That is them depressurizing the vehicle. So yeah, the vehicle is scrubbed. The launch for today's launch opportunity is scrubbed. I'm not sure what the violation is. Hopefully I can get an update here, but we will stand by for an official statement. But yep, okay, so let's keep answering some questions here from you guys. What does Alpha's second stage do to get passivated after completing deployment? Now that's a good question that I do not know the answer to. Juan, man, you are hitting me hard. So the idea is a lot of times rockets, after they deploy something, the upper stage is still in orbit. You're still in orbit, and it's becoming a common tactic to deorbit the vehicle so that you don't leave that upper stage in orbit. And I actually don't know what their plans are there. But man, I gotta just take in one more moment to appreciate the views here. Gosh, what a beautiful launch pad, launch location, and beautiful vehicle. Wow. Yeah, let's take in those views for a minute. Here's what we're actually gonna do. I'm actually gonna take just a quick break here myself and await further information before we give you an official statement on what exactly is going on. But stand by for more information. I will let you guys know as soon as I know anything else. Yeah, stand by. All right, everybody, thank you for coming back. We are officially scrubbed for today's launch attempt. The teams here at Firefly are reevaluating and looking for tomorrow's launch window now. So tomorrow's launch window is the exact same as today, from 3 p.m. Pacific to 7 p.m. So another 4-hour launch attempt. We're waiting for more confirmation. Well, if you want more information about the reason for today's scrub, Firefly might be updating us on Twitter, but I don't know if it's anything other than weather and whatever else they're working with. As you can see here, look at that cloud. So the good news is, though, that we're going for tomorrow's launch attempt. Again, same time tomorrow. I will reset our stream and get us ready for tomorrow. But meanwhile, I just wanted to say thank you all for watching. I did want to mention that we do, of course, have our Aerospike shirt and lots of other fun merch at our web store at everydayastronaut.com. So although we had a scrub today, at least you can take something home with you if you'd like. So we do have a restock on a lot of our merch at everydayastronaut.com. We have a lot of our dress shirts back in stock and lots of other fun things too. So everydayastronaut.com/shop. Shop around for you. Commemorate the current scrub that we have today, or just help support the channel here. It really means the world to me. But we will. The good news is we will see you guys again here tomorrow, same time. But I do need to send a quick round of thank yous. First, thank you all for watching and tuning in, and for cheering and celebrating along, cheering on Firefly and helping them get to orbit. Of course, just by having positive vibes and showing your support, it really means a lot to the teams involved. Trust me, just being positive about this means the world to those on console and those who have built the rocket and are preparing for these missions. Trust me, send them some love and support. But also thank you to my team here that made this possible. I can't tell you how much work has gone on behind the scenes, and it's very much not me. It's the hard work, especially Andrew Taylor, who designed the whole van and runs the show and helps run the show and do all of that. His co-producer, co-editor here at Everyday Astronaut. Just a huge shout out to Andrew and all of his hard work. But Ryan Chalinsky from Cosmic Perspective for helping drive the van out here with me. That was a huge part of this show, was getting the van from Florida to California. Owe him so much love and support, just because it's been amazing to work along with him. I can't wait to see the high-speed footage that he captures of this launch, and of course of future launches, because Ryan and the Cosmic Perspective, Mary Liz, I mean, they're just the best at capturing images and telling stories in a very unique way. So I hope that you guys are familiar with their work. Cosmic Perspective on YouTube and Patreon. A VR, oh my gosh. I think we're going to get some VR from this launch, which is going to be amazing. From closer than any other launch so far in VR, in stereoscopic 180 VR. It's going to be amazing. So huge thanks to Ryan. Ryan and Andrew have slept almost none. Lots and lots of time between the pad and back here, just making sure the connectivity and the cameras are all good. So I can't say thank you enough to them. Allie with Gravity Coast developed the gorgeous layout that we see and the overlay and all the graphics. She's also helping to run the show too, co-directing and technical directing, while Andrew is doing all the other things. So huge team effort there. Huge thank you to Allie. Amazing work. And also to help make the overlay possible, we had Mary Liz Bender, the other half of Cosmic Perspective too, working all night last night to make the overlay work for today's show. Huge. I mean, I can't tell you how big of an overhaul this system is, to be able to be dynamic and do some things on air remotely and do all these amazing things. Incredible. So between Mary Liz Bender and of course Colton Covington with Tomorrow, who developed the Tomorrow chat system that you guys see on the screen, the two of them worked literally throughout the night last night to finalize things, and that's just huge. So but we also here on set, Matt Welch was helping run cameras and do a handful of things too. So thanks to Matt. Thanks to Ben Steinman behind the scenes running the networks even from afar. Steinman's been just a huge help for everything. Really appreciate that. But yeah, like I said, and we also owe a really big thank you to the Space Launch Delta 30 for their support on today's mission, and for even supporting us and our operations here, helping us get on base, on and off base, and helping us do all sorts of things. Vandenberg has been amazing to work with, so huge shout out to those partners as well. But my friends, we will see you guys again tomorrow, same time, 3 p.m. Pacific. So hopefully, we'll let the stream go on as early as we can, as early as we have confirmation that we'll go for fuel up and go for the pads clear and all those sorts of things. We will absolutely bring you guys the coverage as soon as we can. So stand by. It might be a little bit later than 3 a.m. Pacific, but we'll just bring it on air as soon as we can. So we'll set that stream up for you guys, and it's going to be awesome. So All right, sorry, 11 a.m., not p.m. Oh, 11 a.m. What am I? Okay, 11 a.m. I don't know what I'm saying anymore. It's time for me to get signed off because I am not able to speak anymore. So that's going to do it for me, Tim Dodd, the Everyday Astronaut. Thank you so much for tuning in, and we'll see you guys again tomorrow. Bye, everybody.